Okay, can you hear me now? So I want to make sure that the people on chat can hear, on the Zoom can hear me. So you have to select the correct microphone.
Should be she can't hear you?
Oh, now they can hear me.
Yeah.
I
okay.
selected this microphone for my
Right, yeah,
laptop.
that's
Yeah.
for the laptop.
Oh, I see.
This will go through the room.
Okay, got it. So I think we're fine now.
Okay,
And I'm going to also select my own speakers in case they want to talk.
yeah, if it starts to feedback a little bit, just
Yeah.
lower your volume
Yeah, okay.
on your speaker.
Okay, and I've set up my speakers, so you should be able, on Zoom, people can also be able to talk and I'll hear you. Okay, great.
Good, all right.
Great, so we'll get started now.
Does everybody have water? Has everybody been to the bathroom?
Okay, let's go. Okay, well, so we need to stay here, Marvin, for them to hear us here, and as well as on chat. Okay. Well, welcome everyone.
Thank you for being here.
Yes. So we'll get started.
The record button.
Yeah, I did. Well, no. I'm pretty sure I did. Well, I did check. Yeah, it's on. The Zoom recording is on. Okay, so we'll start with just quick introductions from the participants. What would you like to see from the workshop? Your name and what would you like to see from the workshop? Starting with Linda.
I'm interested in everything and particularly how it works and some of the mechanisms behind it.
Okay, so we won't take everybody, Marvin. I changed my mind because it'll take a while and the people on the Zoom cannot hear.
Oh, they cannot hear?
No.
Why?
Because the way microphones are set up, the microphone is only at the laptop. Okay. Okay, so we have to repeat what people say. So
Okay.
we'll just, please have a seat. We're just getting started.
Come on
And
around.
maybe just a couple of other people, your name and what would you like to have from the workshop? Anybody? Volunteer? Yes,
Sure.
go ahead. The programmability, okay. Okay, and then anybody on Zoom, if you want to type into the chat or speak up, even unmute and speak up and tell us your name and what would you like from the workshop? And just one or two people is looking for in general, and we'll get started. So Ron, John, Lanier, Catherine, and Katie, and you don't have to. Okay. Okay, fine, no problem.
They're gonna learn.
Yeah, looking is good. Yes.
QG findings and program suggestions.
Okay, connecting to the QEG, connecting the programming to the QEG. Got it. Okay, great. Let's get started then. So, Marvin, you want to talk about?
A big history lesson?
Well, no, I think basically I want to say, just the way we're going to do the talk is that we'll give a little overview of the neuromatrix, more like the sales pitch and what it does, and then we'll go into the details of each part. We have time to get into the science and the programming and all of that. So we'll do it in two parts. Yeah. And so let me just continue. So, very basic, we know photobiomodulation is beneficial for all the cells in the body. It affects the mitochondria. So in the neurons, there's lots of mitochondria. The maximum number of mitochondria in the brain are in the brain. And it promotes mitochondrial function in various ways and ATP production or production of energy. So it's affecting the energy cycle in the mitochondria, which is where the food is combined with oxygen to produce energy, or adenosine triphosphate, the molecule ATP. So in general, the efficacy of near-infrared photobiomodulation is that it increases mitochondrial respiration and ATP synthesis, upregulates the expression of reactive oxygen species. Now, you may have heard that reactive oxygen species is not good for the system, but small amounts are produced. And anyway, whenever you in respiration and energy production, small amounts are beneficial, actually. And it modulates gene expression and increases nerve cell proliferation and migration, and reduces cell death or apoptosis. And so, for example, it says known to facilitate battlefield and low gravity wound healing, improve inflammatory arthritis, promote skeletal muscle regeneration, and decrease infarct size 50 to 70% in animal models with stroke. That's stroke injured size, basically stroke injury size. And so it's beneficial for all parts of the body. And so Marvin just stepped out, but he runs the Quiet Mind Foundation, and which supports research in alternative areas, particularly photobiomodulation. And he's been interested in, eventually promoting a closed loop system of stimulation. So you can, yeah. So you can talk about the Quiet Mind Foundation.
So we're also working on
Yeah,
getting a
yeah.
microphone. We're also working on getting a microphone for people here to be able to
Okay.
comment.
Okay.
And the people on Zoom can unmute themselves and then we can hear them.
Okay, go ahead. Yeah,
So-
you stay here if they want to.
So
Unless you can project.
Quiet Mind, yeah, I'm pretty good at that.
Okay, fine.
Quiet Mind Foundation started back in 2000 when I was working with, God bless his soul, Len Oakes. And Len and I were really interested in the very low level stimulation. And I was looking for something that would help people with traumatic brain injury because I was doing body-centered psychotherapy at that point. And all of a sudden people were coming in and it wasn't really about their unresolved issues. It was about the fact that they had a car wreck and they couldn't think straight. And so that's when I needed to have something other than psychodynamic psychotherapy. I then learned about Len and what he was doing, saw that it was
This
very
way,
effective.
because we want them to hear you too.
Is there an issue?
There's a microphone here for this one also for the Zoom.
Okay,
So you can talk to them, but stay here.
okay. Fine. This is the first time Sanjay and I are working together like this, in case you haven't noticed. So the long and the short of it is that I started to see, as a result of the lens, people who were struggling with traumatic brain injury and other disorders rapidly improving in a remarkable way. So I then realized that there was a way to combine psychodynamic psychotherapy with neurofeedback, except I thought that neurofeedback was lens. That's the only thing I ever knew, right? So I was starting out from the leftmost fringe and now having to work my way back. People were doing the treatment. He taught me how to do it. I brought it back to my office in Philadelphia and he taught me how to do it. I did it with a couple of people. Their brain injury symptoms remitted within 6 sessions or 5 sessions. It was remarkable. And that was the end of it, I thought. So I put it in the closet and said, oh, okay, now I know what to do when people have brain injury. Then the one person came back and said, funny thing, my allergist took me off Theophylline and said I don't have asthma anymore. Yeah, why are you telling me? Oh, it was whatever we did. I said, no, come on. And they said, no, I didn't do anything else, so it must have been that. Then the other patient I was working with came in and said, oh, my allergist just cut my Theophylline in half and said my asthma is much better. So then I was like, what the hell's going on here? So then I started looking into what is neurofeedback. And then the world opened up in a very rapid way. So I started looking at what's the research base for neurofeedback. And that's when I saw that there was a dearth of research, of the academic research on neurofeedback back in the late 90s. I said, oh, we really need to do some research here. And Lens had no research at all. So I was really struck by that. So I set up Quiet Mind as a way to do research, to support research as an independent organization, not taking money from any of the manufacturers of anything. We were an independent, we've got our funding from donations and research grants that we got. That led along to a study that we were doing on neurofeedback for dementia. And when that happened, I started to look in neurology's literature about what happens to people as they progress in dementia. This was my mom and my grandmother that I was thinking about, like pretty much everybody else. And what there was a continuous stream of studies that all basically ended up saying the same thing. As people progress in dementia, the slow wave amplitudes go up and the fast wave amplitudes go down. So then I started looking at, so when you train or when you do something with people to do that, what do you get? Nothing. There was no research at all because that's not what they do. So then I said, oh, well, wait. I looked at Barry Sturman's work and went, well, wait a minute. If you can make seizure disorder change, right, using this stuff, well, then why couldn't you make dementia or cognitive decline modify? So we then did a study on people in the clinic and people at home. We set up people to do home training and we trained their caregivers to do neurofeedback. And we taught them to train down slow wave and train up mid-range beta. And lo and behold, most of the people started to show improvement across all of the neuropsych measures. Those people who could learn how to decrease their slow wave amplitudes and increase the mid-range, they actually performed better on all the measures. That's when I realized, okay, so what we're doing is changing the slope of decline, right? We're not biologically changing the underlying neurodegenerative process much at all, if at all. In the course of that study, one of the people who was in the study, her husband is a hardcore agricultural biochemist. His wife was showing signs of primary progressive aphasia, so she's losing her words. He comes and sends me an email, and the subject line is, "What the hell is this?" And the link is to the Daily Mail in London. I open up the mail and it says, UK researchers reverse dementia using infrared light. And I'm like, but it's the Daily Mail, come on. Right? And then I went, oh, wait, it's not, it's an article in the British Journal of Neuroscience that's being touted in the Daily. Oh, so then I go to the Mail.
Yeah, stand here. Good.
They can't see me?
Yeah, they can't see you unless you stand here. Yeah, so.
You guys make a good team.
Anyway. So I saw the article and it was an animal study with 1072 nanometer infrared light. And they showed what happened. And we've got some slides to show what happens there. But the fact was, John, the husband, said, well, and I said, I can't punch a hole in what they're doing. These guys are like Caltech, MIT level people at Durham University. This is the head of, biophysics and pharmacology. They're not kidding. So I said, do you want me to go to England and get one of these gizmos for your wife? And he, being a guy with a lot of zeros after his name, said, see if they'll come here. So I'm calling, I don't know who I'm calling Paul Chazot and Gordon Dougal saying, hi, you don't know me, but what would it take to get you to come to Villanova, Pennsylvania and stick your gizmo on this guy's wife? 6 weeks later, we're in Villanova and Gordon Dougal and I are doing the study. And we're doing 6 minutes a day, twice a day. I'm doing the afternoon session. She's been doing neurofeedback all along. We're doing lens and we're doing regular neurofeedback. So we switched out of lens to regular neurofeedback, and I'm coming back to the screen. Sanjay, stand over there and just kind of go like this. So anyway, long story short, 2.5 weeks into the process, Ashley, my research assistant, comes back to the office and is tears. Oh my God, what's the matter? Oh my God, I can't believe it. They had such a fight. Oh my God, she was so angry and they were yelling. I was like, what? Oh yeah, they got into this terrible argument. What kind of argument? Oh, she was saying like, where do you get off making plans to go see our son in Oregon without consulting me? And I'm like, did all those words come out of her mouth at once? Oh God, they were fighting for 5 minutes. And like, blah, 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 and the phone rings. Hello? Oh my God, I can't believe it. She was so pissed. I got my wife back. Click. No joke. I'm sitting, I swear to God, I'm sitting looking at the phone, like, what the hell just happened? And then it was like, oh, the light. The light was the gasoline in the tank that then potentiated the ability of her to make use of the neurofeedback. And he was a happy camper for quite a while, to the tune of $187,000. And yeah, John basically funded the foundation's original research agenda. And God bless them, you know, they're both no longer on the planet, but they're amazing people. Anyway, that started the whole idea that, oh, there needs to be a biological component that intervenes at the biological level to intervene in the neurodegenerative process at that level, at a tissue level, and that neurofeedback is not a tissue level intervention. So really it came down to, oh, really it's both. So that's how this all came together. And where I've been working since then, is, thank you, where I've been working since then is this idea of how do we integrate this whole model into a closed loop system. And I designed and developed the Neuradiant technology, and now am working with Sanjay on the Neuromatrix as kind of the next generation in the progression toward the ultimate end of a closed loop system that will take real-time EEG and real-time heart rate variability and maybe other biometrics and use that to go to the cloud and create an algorithm that'll then drive the lights using z-scores and driving the z-scores to zero. So that's the end of the game that we haven't reached yet. But that's what we're working on, and here we are today.
All right, thanks, Marvin.
You're welcome. There.
All right. Not moving forward.
Presentation directly.
Yeah, I am clicking on it. Somehow it's went to sleep. Okay, let's probably now. Yeah, thank you. Okay, so that's the Neuromatrix headset. And it has 256 LEDs. With each LED is 20 to 40 milliwatt per centimeter squared of power at 1070 nanometers of infrared light. It has four programmable quadrants, so 4 pieces, 2 in front, 2 at the back, and can be programmed from 0 to 19,999 hertz. So any independently in each quadrant. Why would you want to go that high? It's something that I've actually is my discovery that actually that's a interesting and useful thing to do. So the quick. I'm not going to spend much time on this at this point, but near infrared light is absorbed by cytochrome C oxidase, an enzyme in the mitochondria, which is involved in the chain of respiration of combining food with oxygen to create energy or ATP. And it also produces a small amount of reactive oxygen species, which are beneficial for cytoprotective signaling. And it also affects ion channels, gate ion channels at the membrane of the cells, which also signals gene transcription and other beneficial downstream effects. And we'll go over some of this again. So in general, we see that it enhances cognitive functioning, improves circulation by releasing nitric oxide from the cell into the bloodstream, which is beneficial for circulation and beneficial for the cell. It reduces inflammation. That's supposed to be turmeric over there. and it boosts mood. Hey, what happened? Boosts mood, it simulates the release of key neurotransmitters, including serotonin and dopamine, and which play crucial roles in mood regulation, emotional balance, and mental well-being. And then also I discovered in my research that pulsed infrared light at specific frequencies creates brain resonance effects that promote peaceful, expanded, and meditative states. And this happens at a very physiological level, which then impacts the state of mind. So in general, they had said it's been used for brain fog, attention and focus issues, for dealing with trauma and emotional overload, for problems with movement and motor function, and for brain injury and recovery. And so there's, clinical research in all these various conditions in photobiomodulation out there that you can look at, and we can talk a little bit about. Alzheimer's disease, long COVID, PTSD, Parkinson's disease, ADHD, brain injury, depression, anxiety, everything we as neurotherapists sort of get to deal with somewhat in our practice. And there's also meditation research, as I mentioned. And so the Quiet Mind Foundation in Marvin has been working quite actively in the using 1070 nanometers. So the general standard of practice in the field is 810 nanometers. And there's a lot of research on that. And that's what, companies like V-Light have been using, which is great. And so Marvin, you want to talk a little bit more about that and the Cognito light?
This is the history lesson that picks up where the Daily Mail left off. So what you're seeing on the left is the original Cognito device. And that's what we were using with the person in Villanova. So you can see there's panels, like arrays of 70 or so LEDs, and they're bullet LEDs at 1070. But there are also 2 arrays that went directly into your eyes. And so that program was delivering about 32 watts of irradiance to the scalp all over. And what we were using then was a protocol of 6 minutes. And we looked at the research and saw that a 6-minute dose was probably going to be most useful because there is a biphasic dose curve in terms of photobiomodulation. This is just some PBM gains that are in the current news these days. I just wanted to show you. There was a study on normal subjects that was done in the UK showing that people who without any pathology were showing similar, almost the same cognitive and motor benefits as the people in our clinical dementia study that we did at the Texas A&M Baylor Scott and White Hospital Department of Neurosurgery in Temple, Texas. And that, for me, was really important because in order to talk about prevention, you first need to be able to talk about improving a pathological condition and then be able to show improvement in the normal population. So now it's preventative. So that was really helpful for me. Like I said, I developed the Neuradiant technology, which was the outgrowth of the research that we did in Texas, where it was a continuous delivery of light. There was no ability to pulse. There was no ability to segment the delivery of the light. And the person, Dr. Dougal, was very set about that's the way he wanted to do things. So I said, okay. And then I went and found a Chinese manufacturer who would modify the devices that they had been making to my specifications. And then I found some people in Europe who would help develop the protocol program and do it as a for-profit entity that would then throw off profit that would then go to the research that we needed to do at the foundation. Skip ahead a couple of years, and where I am now is I took back all of the research and consulting responsibility back under the Quiet Mind umbrella, and then found Sanjay was using the Neuradiant model with an improvement on the technology at the controller level and being able to use it for meditation practice as well as for other neurodegenerative and other conditions. It was great. So then I partnered up with Sanjay and said, let's move this forward. And here's where we are. So that's the history lesson. I have to sit down.
Okay. Yes, please.
Go over specified program on that. I have those.
Sure, you mean the neuronic?
Uh-huh.
Sure, yeah, absolutely. At the table?
Either way. Other people might want to know too.
Let's have a neuronic? Oh, look at that, okay, great.
I don't know if it's new
Okay.
or matrix.
Yeah, so what we're working on now is the neuromatrix. So people have the neuronic, and Marvin can help you with programming that for sure. Yeah, absolutely. And just come to our booth. That's the best way to do that. Yeah.
For a donation to the foundation.
All right. Okay, so we thought now we'll go into more detail. Please feel free to stop us at any time, and we'll move forward with that. So this is a slide of the kind of research results on photobiomodulation therapy, like 11,000 papers coming out currently. That if you just do a search, that's what we find. Yes.
The presentation is now.
Oh, okay. Thank you for reminding me. Okay, let's make sure it's playing on Zoom.
Has a question.
No. All right. Let's just keep going. So I wanted to just go into a little more detail on the action of near-infrared light. So as I said, the near-infrared light is absorbed by chromophores or photoacceptors in the mitochondrial respiration chain, and particularly cytochrome C oxidase. It's one of the effects is that that nitric oxide is bound to certain heme molecules, and in the course of the action of the respiration chain, which is then when light comes in and is absorbed by cytochrome C oxidase, it donates an electron and releases nitric oxide, which is bound to heme, into the bloodstream, and which is then replaced by oxygen. So it sort of resurrects the cycle and regenerates the cycle. And nitric oxide is beneficial in the bloodstream for improving blood flow. The reactive oxygen species activates transcription factors in the genes and provides for beneficial signaling, which improves cell regeneration and cell reproliferation and other beneficial actions. So it also, besides increasing cell survival in that way, cell death is reduced by the expression of certain proteins that inhibit cell death or apoptosis. It's from a paper by Huang and et al. On the biphasic dose response in low-level light therapy. And also particularly interest to us that heat and light gated ion channels are activated, and typically calcium flows into the cell, which can also activate and generate action potentials in neurons. So normally action potentials are generated by sodium ions, but in this case, calcium ions can flow in and also create action potentials. And so TRPV is a receptor beneloid channel or something like that. It's activated by heat, acidic conditions, as well as by light, and plays a crucial role in sensory perception. It also allows calcium and sodium ions to enter the cells, leading to depolarization of nerves. This is a complicated slide that says, okay, well, there's a reason why apoptosis is improved. There's less cell death.
This is the slide. This is the slide that I put in all of my decks. and I say, is there a cellular biologist in the audience?
Right.
Okay, now that you see this slide, you know I'm not kidding.
Okay,
So they understand that
I
this
don't
is,
understand it, but yeah.
yeah, it just means that the apoptosis is being interrupted. Yeah, Cindy.
A mutated cell like a cancer
That's true. It can be beneficial for senescent cells or otherwise damaged cells.
activate cancer, so how does that work that,
Mhm.
it doesn't kill off cells, but cells that need to be killed off get killed off.
That's right. Yeah. So it improves cell survival of healthy cells, but it's generally improving the metabolic activity. So it doesn't have anything to say about senescent cell apoptosis. The research doesn't indicate anything plus or minus about it. So that will just follow its natural rhythm.
And one of the things that you should consider is that this type of intervention is increasing the immune system's capacity to function.
That's for sure. Yeah.
And so we're building the CNS's capacity to do its job the way it knows how to do it. And now it's having the resources to actually do it. The only data that I collected from a consultant photobiologist when we had the IRB review for the original study that we did, they did an extensive literature analysis on 1070 and cancer. What they showed was that angiogenesis was not promoted in the literature by 1070. And that was the main issue that the IRB had, was about, blood vessel development to the tumor, and there wasn't any.
So it also
Good
general, yeah, there are no clear indications that it activates cancer, and there's no clear indications that at the moment that there's not a lot of research on preventing or treating cancer with it either. Now we have some indications that, for example, in cancer cells use glycolysis and an active glucose metabolism using glycolysis, which is not the same as regular respiration. So, and the mitochondrial function in cancer cells is downregulated, in fact. So the indication is that by adding light and activating mitochondrial function and activating the standard respiration chain instead of glycolysis, that is probably beneficial in some way. But that would be one of the things that we could say. But there is no being clear indication that it's damaging to cancer, and it's certainly being used for chemofog, for example. Red light can be very beneficial for dealing with chemotherapy, fog, brain, etc. So here's just a list of different possible benefits, including increased neutrophils in the immune system, reduced neuroexcitotoxicity, increased synaptogenesis, increased antioxidants, increased neuron progenitor cells to create new neurons, anti-apoptosis, anti-inflammation, increased blood flow, and then in certain cases, yes, increased angiogenesis as well, maybe not so much for 1070. So various conditions we could work with: traumatic brain injury, dementia, Alzheimer's, brain fog, chemo brain, COVID, long COVID. There's studies on all these: depression, PTSD, stroke, Parkinson's, peak performance in general, brain health and wellness, which is really the indication for this device, meditation in higher states, and improvement in, general navigation, reaction time, energy, and mood. So we can talk a little bit about
This is good.
the absorption spectra of chromophores in human tissue, where there's some conversation about whether to use 810 or 1064, 1070, etc. So what this is doing is showing how much of the light is absorbed by water, blood, oxygenated hemoglobin, and melanin. And one reason you can see 810 is used is because it has low absorption by water. That's like the so if you look at this square here, that's low absorption by water right there. And then you compare and you see, okay, well, the absorption goes up, but not around 1070. It's actually still low. Yeah. So it's actually still low at 1070. So that's one reason to use 1070. Okay. And then we have, for example, hemoglobin, and you see hemoglobin absorption here at 810, and it's actually lower at 1070. And if you look at melanin absorption, it's pretty high for 810 and lower for 1070. So you see, you know, that these are two windows that can be used. That's sort of the reason we use 1070 and not 1000, for example, or 940.
And 1070, 1060, 1070 has been shown to be the peak transmission in the pure water. So now that there's a lot of talk going on about structured water and the influence on structured water, 1070 seems to be a potential for increasing the information transmissibility in the structured water.
So actually this, yeah, let me, go ahead.
Like, is this within its peak absorption?
Yeah, so actually the current literature says that 810 nanometers is better absorbed by cytochrome C oxidase than 1070 and has more mitochondrial activation effects. However, so far it is all new. So far the indication is that 1070 is better in its signaling. So 1070 is better at signaling the ion-gated channels and is better, and because of its higher, slightly higher absorption in water, you'll see that the 1070 is actually has slightly lower transmission in water than the 810. And that's what that slide shows. And it's better absorbed by water, which is actually beneficial to a certain degree because the water is present in our cells, not in just a regular form, but in a crystalline form, in an exclusion zone. It's called easy water, exclusion zone water. It has like this membranous structure and it carries information. And so when you pulse the 1070, that information is absorbed, is connected to the water, and it also acts like a battery. And when the water is repelled by the sort of the fatty membrane, it produces a charge on one side, plus and minus on either side. And when the light hits it, that charge increases. So it acts like a photo battery. And that photo battery then activates ion-gated channels and signaling in the neuron. So it has a different mechanism, not just the cytochrome C oxidase. So there's two mechanisms going on here. One is the photo battery and signaling, ion signaling aspects, and the other is the cytochrome C oxidase aspect. So the 1070 has less of the cytochrome C oxidase effects, but more of the signaling effects. And so it turns out that overall it's very beneficial. It does both. And 810 does one, less of one and more of the other. So in the future, you know, we're thinking about just combining the two. We might add some 810 nanometer LEDs to our headset, for example. But we prefer the 1070 overall.
The two circles are significant because a lot of the economics that went into photobiomodulation to begin with was that NASA did their research back in the 80s with 810. So the price of 810 diodes was pennies, where the price of 1070 was $4 a diode when I started looking at them in 1998. So again, that was the economics of it. But here you can see, go back that one.
Okay.
If you see, no one really looked past the drop off at 820. Right? They didn't look at, and they didn't see that what was coming back up, what's significantly coming back up was at that 1050 to 1080 spectrum. So now we're looking at it because it means that you're getting deeper penetration, but we're also seeing that it's activating heat shock proteins.
Yeah, and it's a deeper penetration because it's a higher wavelength.
Right.
Higher wavelength means it can go deeper into the tissues.
So using those principles, you're starting to see that we don't really, I certainly don't endorse, and I know Sanjay doesn't, the idea that there's a better, that we don't know enough to be even start to talk like that, right? And I wouldn't encourage anybody to talk like that, but we can certainly talk about what are the benefits that we see from the different wavelengths. And one of the research studies that I saw from China a while ago, the hint was that 810 may have something to do with survivability, whereas 1070 had more to do with synaptic and dendritic development. So that was one of the interesting things about why might we want to create a combined delivery system, and how would we do that, and how much of what? I mean, there's a million questions that brings up, but it's a very important avenue for our research.
Yeah, so we've talked about adding 810, and Relight's talking about adding 1070 to their system. So that's where we are. Mhm.
Yeah, in 2017, I brought Lou to Orlando, I think. That was the first, right. So I brought Lou the way I'm kind of bringing Sanjay and going, right, because it's really important. Like, we really need to put these things together.
Okay, so you want to explain this?
Speaking of penetration, this was a study done back in 2000 at the University of Bristol, and amazing that, they had people in the operating room during a procedure involving craniotomy. So they were actually live patients where they were putting an emitter on the scalp surface and then detectors at every level of tissue down to the cortex surface. And they were measuring the penetration. And so what they saw was that, do I just hit him? So what they saw was that the bulk of the diffraction came from the skin. And what they also saw was that bone had very little to do with loss of signal. And that made sense when you think about the crystalline structure of the bone being like tubes, like fiber optic spaces, where the light just went right through to the cortex. So there was also some minor amount of CSF and dura involvement. But what it means is that they were getting at least 6 to 10% of the light energy based on the power of the emitter. They were getting 6 to 10% down to the cortex surface, and they were getting down 3 to 4 centimeters.
Yes.
Boy, is that it's a definite impediment. It's an impediment.
Yes.
Shave your head?
Well, apparently, when we use it with, women have more hair in general, it seems to still work well. So,
Properly designed cornrows.
yes.
I had read somewhere, confirmed before me would, that the dura is actually the most opaque. It's not the skull. One would think it was the skull.
The skull, if anything, the dura has not been fully explored, but that opacity has something to do with the spread, the diffusion of the signal. So what I want to get to about laser versus LED, we'll get to in a minute, but it bears on that. Thanks, John.
Okay, this just basically is repeating what we were talking about earlier about using both. So you can reach deeper brain structures with 1070, and 810 will be better for cytochrome C activation, 1070 for signaling and maybe even markers of inflammation. And so ideally, eventually we'll combine them. Here's another study comparing, actually, so that's the conventional idea, but here's another study that's interesting to look at. And that is comparing 810 nanometer laser and 1064 nanometer laser and LEDs as well. So I'll explain this in a second. So here's a comparison of 800 versus 1064 nanometer laser with in terms of oxygenated hemoglobin activation. Okay, and you'll see here that the actual activation. So here you have like a greater activation of 1064. That's what that graph is showing. In terms of as the minutes go by, you get greater and greater activation with the 1064 laser as compared to the 800 nanometer
Right.
laser.
Crypto is 100%.
And then here lower, we have activation of cytochrome C oxidase. Here you have the 1064 laser activating the cytochrome C oxidase more and then dropping off more rapidly with time, while the 810 activates less and maintains better over time. So, it's hard to compare. And here's a comparison with 810 nanometer laser with LED. Okay. And what you'll see is that the laser is definitely activating better, but the 810 will slowly go through a cycling and get close to the activation of the laser. Wait, is that correct?
Nope.
Yeah. Oh, yeah, that was an oxidated hemoglobin.
Mhm.
But now if you look at cytochrome C oxidase, you'll see the LED catches up to the laser after a while.
And
So
when,
it's pretty comparable.
and when you turn off the laser, it drops like a rock.
Yeah.
But what happened is that the activation from the LED continued past over 4 or 5 minutes past when they shut the lights off.
Oh, yeah, that's something to say. You know, this pink area is when the
Yeah.
light was on, sorry. The pink area is when the light is on. So this is light on, then it gets turned off. On, turned off.
So
The
then,
light is on, then the laser starts to drop here. The laser starts to drop, but the LED keeps going up in this particular case.
yeah,
Tissue culture or?
on the forearm of a subject.
Mhm.
So, you know, a live person.
So here's a 1072 nanometer photobiomodulation research done on mice bred to have Alzheimer's disease. And they were exposed to 1072 nanometers infrared light for 6 minutes for 14 days and showed significant reduction in beta amyloid levels and improved behavioral outcomes.
I just want to make one point. This is the
Mhm.
study I was talking about before, about the Daily Mail. And this is the study that was published by Paul Chazot, Professor Chazot, and Enisur and Gordon Dougal from Durham University.
Great. And so these are some pictures showing what happens when the light shines on the tissue for 3 minutes, 7 minutes, and 12 minutes.
And this is the development. This slide is the development of the plaques, the small and medium-sized plaques.
Mhm.
So you're seeing how it happens over the course of 5 months,
No, wait.
to a year. Yeah. And then the next slide. This one, yeah. Now you can see the difference between the sham and the irradiated mice. And the one on the right is significantly less plaque. So this was, for me, the smoking gun about the biological benefit of photobiomodulation at this wavelength. Now, there are also other benefits in terms of
So if
the
you
beta
look here,
amyloid. The
if you
beta
look
amyloid.
here, the beta amyloid here is sham is shown in here, and the active is shown here. And here is a graph showing the bar graph showing how much beta amyloid is expressed, and it's here in the sham. There's a lot more expression of the beta amyloid than in the active.
Yep.
Did they see any differences in mouse cognitive skills?
Yes, they
Yeah.
did see. Yeah.
They ran radial arm maze trials. I'm sorry, I don't have that slide, but I have it. There's a radial arm maze trial that they ran the mice through, and they showed a significant improvement in memory and anxiety response in the radial arm maze. But then it was great. They ran a trial of normal adolescent mice, and the treated older mice beat the adolescent mice.
This way. Yeah. So the older mice beat the adolescent mice. Okay. And
There's
not-
hope for us.
Okay, I think we can go forward.
Or you like this one?
So this is a study that I found, which is in just production of nitric oxide in basically a human endothelial cells, as vascular endothelial cells. So this is a tissue culture study. And this was exposing to different lasers. 1064 nanometers laser is A here, and then B is actually no laser, is actually, 1270 nanometer laser, and then C is 808 nanometer laser. And on top you have no laser, just stop here. So you can see how much more activation is as you increase the wavelength. So going from 1064 to 1270 increases the activation of basically new cells being generated. And 808 is much less. This is in tissue culture though. So there's no absorption by water here, interfering.
Question? We're good.
I think we'll skip this one for now. So in general, we have other speculation on how the light is operating. There's some sense of the light operating in the subtle field. Light operating, we don't have sufficient understanding of how the light operates in the brain. And there is research on the idea that there's microtubules in cells which act like photon waveguides. And there's a lot of light activity happening in the brain at quantum levels that we don't understand yet, that this light therapy could be affecting. And I suspect it is. So we're not going to go into that in more detail because it's kind of speculative, but it's definitely an area of interest. And you can think of, photons traveling through exons, which act as waveguides, or through microtubules, which are much smaller structures in cells, and which, resonate at very high frequency. And then, the light is somehow traveling through those cells, through those structures. And there's light signaling in cells as part of their normal functioning, which we are yet to discover. And we may be impacting those with the infrared light therapy. And so certainly also quantum effects and higher level in quantum entanglement effects, which are certainly possible and are starting to be looked at.
Well, this is something we were talking about a minute ago about biophotons. And what we're seeing that the biophoton correlates with cerebral energy metabolism and EEG activity and blood flow and oxidative processes. So there's definitely a synchronization in terms of phase lock and phase reset that are going on and interhemispheric coherence, which is something I'm particularly interested in terms of understanding how we can influence normalization and more efficient brain function by influencing coherence and using the light to differentially stimulate left and right hemisphere and flip them back and forth. And that's why I developed it with 4 quadrants, so that we could flip back and forth and front and back at different frequencies in order to stimulate or reactivate that bilateral connectivity.
You guys
Because
know what biophotons are? That the body will generate photons, very weak emission of photons. That
ultra
can
weak.
be ultra weak emission that can be captured in a very dark room. Yes. And yes.
So you were explaining that the biophotons, is that, remember those tabs for the light bulb? That is? Oh, good. Never mind.
Okay. All right. So moving on to just some terms that are useful to understand in PBM. The difference between irradiance or intensity and fluence and total dose. So irradiance is intensity of at a particular point at any particular time, how bright the light is. So you can say measured in milliwatt per centimeter squared or joules per centimeter squared. So, for example, we said the helmet is 20 to 40 milliwatt per centimeter squared, or the wheel light is 100 milliwatt per centimeter squared. So it's brighter, shining brighter, or how bright it's shining. And the power decreases as the square of distance from the source of power. And fluence is how much is delivered over time to a particular spot. So it's measured in joules per centimeter squared, but you multiply by time. So if you have 20 milliwatt per centimeter squared for 10 seconds, then you get 200 milliwatt fluence per centimeter squared. So it's multiplied by time. And then total dose is the power, time, and area. So how large? So there's, for example, the Neuromatrix headset covers a large area. So it's delivering a high dose over time than over a few LEDs that are covering just a little big pieces of area. So you have to multiply by the area to get the total dose of light going into the body. Does that make sense? So we have irradiance, fluence, and total dose. Yes.
Just out of curiosity, are these wavelengths part of natural sunlight?
Yes, they are.
Absolutely.
Yes, they are.
What's the
I think, that's a good question.
Who's got ChatGPT?
Yeah. I think that's what I was going to say. It's about 100 milliwatts. Yeah.
So the study that we did with the larger device, we figured that the irradiance was the equivalent of standing at the equator at noon for 100 hours in a row. And that's what you were getting in 6 minutes from the device at 1070. So in order to get the equivalent 1070 dosage, you'd have to do that.
Yeah. So that's the irradiance of sunlight itself. But the question is, what is the irradiance of 1070 nanometers in that sunlight? Yeah, that's very small.
But it's 85% of the reason there's life on Earth. So let's not kid ourselves, right? Near infrared radiation is
Very beneficial for the system, and
Yeah.
getting sunlight exposure is beneficial for all sorts of reasons. right?
Everything.
Yeah. Because there's all the other wavelengths also have beneficial effects. Yeah. Yes.
And then they talked about milliwatts, and milliwatts is 1,000th of a watt, right?
Yeah, as a thousandth of a watt, right?
Like watts, it has to be like tiny.
Yeah, so that's what it is. Most light, the light being emitted is in milliwatts of these devices. It's in milliwatts. Yeah.
Right.
Yeah, that's hard to get into. I mean, people can claim anything, and typically they can claim the power of the power supply, which is not the same as the power of light. The power of a current going into a circuit board is typically in the order of watts. That 40 watt would be the power supply, but that has very little to do with how much light is actually being emitted. What is the power of the light itself?
Wattage of like a bulb.
That varies. So in our case, we have LEDs emitting 20 to 40 milliwatts, but there's 256 of them. So you get a lot of light, total dose. Yeah.
And you don't want to generate too much because then you're causing heat issues
Yeah.
that then have to be exhausted.
So then if you increase the wattage a lot, then you've got to put in a fan, for example. Yeah.
Which is why that original device looks like Darth Vader.
So the incognito light had fans on each one. So we're still learning what is the optimal irradiance, how much does irradiance matter, how much does total fluence matter, how much, so it's all in the art of treatment and seeing what the results are with different devices and different studies. So in fact, what is the right dose? It's the next slide. So looking at the fact that we have a biphasic response to in light therapy, and that to a certain level you have to increase the irradiance, increase the fluence to get an effect. But if it increases too much, then it goes negative because the body's overstimulated, too many reactive oxygen species are being generated. In general, even with this helmet, if when we give it to a client and we say if it's too much for your system, then you'll get a headache, you'll get thirsty or tired, then you stop it. You don't keep using it, and drink some water, take some vitamin C, deactivate the reactive oxygen species, and or use it with glutathione or something, and then as your system adjusts, you can handle longer. So for some people, we start them on 1 to 4 minutes a day. And that's what they need to do, and then build up to, for our headset, it would be like up to 30 minutes a day. Yeah.
This just made me think of something. So is this the biphasic response mechanism, is it individual to the actual person, or is it something to do with their underlying whatever they're?
It's both.
Absolutely.
Yeah, it's both. Yeah.
And you do have to discern all the time with experimentation, obviously,
Yeah.
dosage, what's the right sweet spot for
Right.
that person.
Yeah.
And
Yes.
Do you have any predictors of those response?
Thank you.
Yes. The more the body is dysregulated, the more sensitive they're likely to be. So you start slower. And then certain people are known to be sensitive to therapies. They say that I'm very sensitive to whatever I take. And then if you're one of those people, then you will just be cautious with them. And certain people are less sensitive. They're like, I don't feel anything. Like, okay, well, let's start you with 30 minutes. right?
I would certainly use the ACE questionnaire for that.
Mhm. Oh, that's a good point.
Thank you.
Yeah.
I got an A.
Yes. Somebody say anything? Oh, okay.
Got an A.
Yes. All right. So, for example, here's a study that showed that increasing the irradiance was important and helpful. You have, you have a laser exposing at different power densities in treating post-herpetic neuralgia of the face. So, treating pain, nerve pain in the face from herpes. And as you increase the power, we get actually not just pain, but the wound. So actually the herpes wound on the face. And as you increase the power, you get a better response in the wound healing. So going from 4 milliwatt to 15 milliwatt per centimeter squared.
Oh, meters square.
Yeah. Well, that depends on here they're using a laser. It's just a study with a laser. Yeah.
A study that used, that's one point, a study that was used in 2014 by Celine Lee in South Korea. She had rodents injected under their skin with MRSA, and the lesions that formed, they then took half the animals and they sacrificed 2 at a time every hour. And they measured with assays the generation of VEGF and a bunch of other growth factors that would be promoting healing. And what they found was that at 12 hours, the level of VEGF production in the ones that were given the 1070 was 14 times greater than the sham. And there are photographs of the animals after, I think, 5 or 6 days. And the sham animals looked like terrible messes on their skin. And the ones in the treated group looked like they were scabbing over and getting better. That study, if anybody wants it.
So this is a wound healing study that showed that increasing fluence up to a point is useful. Fluence meaning the product of the power with time. So how much treatment you're doing, how much treatment you're doing per centimeter squared. So you see a clear maximum at 2 joules per centimeter squared. That has the best effect on the wound. Is you increase the time and the irradiance until you're delivering 2 joules per centimeter squared for this particular study. And whatever all the conditions were, I don't remember, but just really demonstrating a biphasic response. As you increase the fluence to 10 joules per centimeter squared, the response actually drops off. The wound response worse, it takes longer to heal. Okay, so we talk a little just a bit about pulsed photobiomodulation, which is pulsing at various frequencies. We know about entrainment. In infrared light, some of the entrainment happens at a physiological level by gated ion channels that are activated by light. So as you turn the light on and off, ion gated channels are activated and deactivated. So it's not just neurons firing. It's like ion gated channels activating and deactivating. So this is a study by V-Light with their gamma device showing that when you pulse it at 40 hertz, there's an increase in various bands, including alpha, beta, and gamma. That's the device they were using. And we also can look at, the idea from repetitive transcranial magnetic stimulation that in repetitive transcranial magnetic stimulation, 10 hertz actually activates the tissue in the brain, and 1 hertz actually inhibits the tissue in the brain. Similarly, in alternating current stimulation, we can do theta frequency alternating current stimulation, which inhibits activity in the brain, and beta frequency alternating current stimulation, which activates the cortical region where it's applied.
That made me think of something.
Mhm.
The people familiar with theta burst TMS, where they burst, 5 seconds of theta they use the they use the magnet to burst like 50 cycles of 7 hertz. And what they're finding is that by doing that burst, they're decreasing the amount of time that people need in order to get the antidepressant benefit. Goes from something like 30 minutes to 3 minutes. So again, it's this idea of how you stimulate the channels and how you make the tissue more permeable for the intervention to have an effect.
Okay, so now we're getting more to the clinical application part of the talk. So I have a question for you guys. We've been talking for more than an hour. Should we take a break before we do that? Okay, great.
Take 10.
So we'll take a 10-minute break, or what's the time now? It's 4:40. So we'll be back at around 4:50, 4:50, 4:55, between 4:50 and 4:55. See you then. See you before 5. Thank you.
No, do it again, do it again. Oh. Yeah, all right. We're getting the dance slopes together. There's just so much to cover. Thank you for filming it. I want
What's up?
I want one.
The water?
No, the film.
Oh.
Oh, okay. Well, I'm gonna get the.
So that you have to make your control.
I can't hear very well. Got a question?
Oh.
What you said.
What would it
Right, something the body can.
Like, would be the, or oxygen, like, kind of there, bring down a little bit of
Oxygen is really,
yeah, correct.
really difficult. It has damaging effects. Yes, what, especially things like, it's just, it's important. But I wanted, I wanted the thing that had the lightest touch.
I'm curious, this time, it makes sense to me.
Oh, good. That's my favorite one.
Just it's interesting to see that it's first time I've heard that. I mean, I've studied. Oh, is it?
it is.
We've been affiliates with Buffalo for years.
I'm not trained with Buffalo, but I follow, I do the Photobiomodulation for my patients.
Your doc.
Yeah, I'm a physician. Integrated.
One of the.
Yeah. I was-
Oh, no, I met.
So this research is hopefully promising.
It is.
And one of the challenges with this research is what the proof is.
So this is a very good, very powerful.
Study the use case is, and it's got
It's not a home use thing, but it's a clinic.
in the
Some people don't. Yeah,
yeah, certain local,
Yes.
sport.
And I guess the question is really.
It's
Probably not, right? I mean.
Well, the challenge I have, I try to do that and replicate my clinic, you can't, because
Yeah, I mean,
they were
also treat less.
they're feeding them,
Yeah.
coaching them.
That's why they created Neuron.
Yeah,
That's why.
Well, I guess you're right, yeah, that's something, that's what they did, a study, I believe.
Oh, yeah, Heather Sanders,
Yeah, Heather.
that was the whole thing.
That was, yeah.
So.
So the problem is that because we do that,
One is the
but when I
focus
give
on
patients things and I
the
see.
intensity,
The husband or the spouse or the kids are like,
the other is
they're not.
the
doing
effects
it.
of frequency, which are less.
It's really hard to.
So.
It's
And the high
So I'm like,
frequency. It has
best I can
very
do is.
strong effect.
There's people, but
It's at a
Unfortunately,
subtle level, but the.
as exciting as this
frequency
is, because I think if we can find other ways of creating energy in the system.
No,
That's
frequency.
all that is. I mean, I still want keto, to go plus.
We have a module that can pulse our devices from one to.
Yeah, but the question really is, do you need to.
Okay.
Have power.
Yeah.
You can
See how there's only one blank?
get benefits.
Yeah.
See how there's still only one blank?
Yeah,
All of those citations are about photobiomodulation.
yeah,
Shoulder, it's like.
All of them.
yeah.
So all of the holes in the roof and the ones that he didn't cover, there's,
It's so, yeah.
it's obvious. When you stop, you go, oh, wait.
Well, I don't, okay, well, I'm excited, good, I'm staying.
But it makes
I'm staying for the rest
complete
of the
sense.
show.
It makes complete sense.
Yeah, okay, good, well, I appreciate it.
And where are you?
I'm in Mason.
If I understand.
No, but we just started hanging.
No, it's a great advice. It's a great.
You have to hang out with me.
Oh, yeah, I just bought an helmet this.
Oh, good for you.
So,
And I can consult, you know, I'm part of the group, so I can consult around clinical application. So if you have any questions like that.
Oh, we should. And the tools delivery is only a third of what we do. In comparison, because we can deliver more jewels, because there's more actual light power delivered at a lower radiance.
There's not major changes in most 40-year-olds, but the thing is, when I get like 7, 5, 8-year-olds, and then I've got 7%. It's really about the. That's why I'm interested in
They
this.
take this home
I want to take this home and
and they take it home.
yeah,
They have to take it home because they're not gonna come to your office sick twice a day.
no, well, no,
They're not.
no.
Right.
They're not very, it's interesting as they get older, they get to these situations, they're not very supportive.
Oh,
It's trying to help them.
Oh, no, yeah. Oh, really?
Bad, like opposition, like kids, this is just again.
No, no.
Opposition.
There is there's several really important papers that showed that there's a reverse ontogenesis that
Yeah,
happens along with.
yeah, you can see it, yeah,
And so you
Makes
really,
them hard.
you really are dealing with children.
yeah.
And then the family is super pissed.
And the family gets frustrated, they get even angry, they're trying, but they push them back on everything. I don't want to change that, I don't want to do the helmet.
Find out, I
So,
think.
yeah, so I've been using V-Light and still will use that.
Sure.
Moment.
Once you get, go pee.
No,
Once you
I'm
get-
not, I'm good.
Once,
I go 8 hours.
really?
I'm from Arizona. You know.
Oh, that's right.
You gotta retain your water.
Oh, Jason, it's great to meet you. It's really-
We'll talk. Good to see you again.
Well, this is fun. Is it okay? We doing all right?
Sorry, I'm like bothering you with the Zoom thing, but it's important for people to be able to.
I'm not bothered. This is absolutely the worst framework for me as a presenter. I never, ever stand behind a podium. Never. I just never. And I absolutely hate this. Right?
Yeah, no, I
I
mean,
hate that. It's like I didn't want to go to academia and do this. I know. There's no reason for the lavalier and this is a
staff councils will limited
budget.
budget to for the AP, so
If you would have told me, I would have brought my own camera, and my own. But it's okay. No, it's
That's good to know
okay.
because
Absolutely.
in
the future,
feedback is important to improve.
Let
things in
the
future.
presenters bring their own presenting
Yeah.
to whatever degree they can. Because, you know, well,
No, that's
this is
okay.
plug
I
and
mean,
play. It's plug. and
Okay,
play.
all right.
It's plug and play.
I mean, it's,
But it's just great, and please keep going like this. Yeah. Well, I learn? I kind of learned, right? I'm just a smart rat.
That's not like it's funny because you're like on the both ends of the Zoom screen, like
Yeah.
They're both
Are we really like that?
sometimes you're like just, but still within the
Why
screen. So that's
haven't we
good.
heard from anybody on the Zoom? What do you think that is?
They're used to that bitching about it because they're home, with their feet up and they're.
Oh, right, but they're not asking any questions either. So we should bug them about it. We should bug them about that. Let me get this slide out of here. This is too, this is later.
Which-
Nah.
That's important. Yeah, all of that. Yeah, no, there are no questions.
Did the recording pick up all of what we were just talking about? By the way. We have to be mindful of our hot mic.
Yeah,
Now, does V mic go up to 20,000 hertz?
I would never. He did it for 10 minutes. And he was practically unconscious.
I mean, the device itself.
It goes to 20.
No, I know yours goes. Does the V light, does the harmonic?
Oh, always remember, radiant and neuromatrix are literally the same device.
Oh, okay.
They are literally the same device. Sanjay just went to the manufacturer and got them to change the color of my device.
Okay, no, but I mean, you're,
Which, no, and this is just a fact. Thank God he did it.
I have the original Veronic with the big giant box, right, that does all the quantum training.
It's exactly the same
Okay,
thing.
so, yeah, all right, so that, I'm gonna take away from that, I've never done it, that you can program the Veronic to 20,000.
Oh, sure. Do not do that.
No, I appreciate that.
That is not on the menu. It's not what we do for a living. It's what he does for a
For fun.
meditation living.
Yeah.
God bless him. No patience, no.
No, just for
Nobody
myself.
coming in your office.
Just for myself.
I don't care what you do. You're a grown up. I love you, so don't do it.
And it's a dual
No, actually,
Two for
Oh,
one.
I think
yeah.
the hand is.
Now,
I think for the hand,
I think I hooked himself up to
it's
the
still
device.
not an ideal format.
And just set himself. Psychotic.
It's like, I like that, the movie.
Yeah, no, it's-
Remember the movie
Just
Powder?
from a practical perspective, setting it.
Powder with the kid was all white.
Yeah.
And then at the end, he just turns into a rainbow. Then
And
it's just-
also, I think about,
I wanted to use that as a clip for, hey, this is what we might be able to pull off. Anybody interested?
Get takers, you will.
I'm curious, have you, had like using it actually been?
I know my wife.
Okay.
Like,
Just
like I
like
said. Oh.
Parents brought their.
Well, there's a difference between 10 milliwatt.
With clear diagnosis from the school.
160.
And I did 5 sessions with the kid with
You're putting out
neurofeedback and
one joule
photobiomodulation.
or you're putting.
And when they
That's
went
a
back,
joule, but
the IU
So what,
intermediate unit said, oh.
I want to create a website for meditation, so I'm not necessarily looking for really high power.
And how young?
We're looking at some, just,
How
we're
young?
looking, experimenting right now on some lower power things that are
So
gonna be.
you've done it on stream on.
It'll be introduced, we're just right now looking at it, which could be used first in office combinations or that's potentially.
Well, you see meditation is a different.
But they're doing-
Yeah, it could be useful.
30 seconds.
Reset it kind of agreements, what kind of reset that plan you have, I
Okay.
think we want to reset.
And that is information we can find
if
like on
any.
the.
We do have
No,
one of the distributors and they will get a
Okay. that's
portion of
perfect.
what they
And,
sell.
All Marvin Nest.
Probably like a commission element based to some degree.
That's
And referral
NR1.
publicly.
You're kidding me.
I'm not directly in the marketing side of things.
We can have that conversation, like come here and tell people.
You can get answers to, so you can inquire about,
That it has value.
No,
I
just
believe
keeping
in
the power rules, make sure all these work come together. And all of these
Absolutely.
devices come together.
There,
And
not now.
balancing the ramping of
You know,
what
if it
the
was-
demand gonna be in 3
Well,
months.
no, it's just.
Mhm.
all the numbers.
Which is really important and it's kind of like grasping at straws at the same time. So it's-
Right.
But it needs to be done, so.
Yeah.
And then,
So,
quality control element is there,
I started here,
just interacting with the workforce.
they took all of my technology.
Finding out,
And I.
it's a balancing act between the different sectors in the business.
Yeah, no, it's probably there, so from my side, it would be, looking at. If I want to create a new device in cooperation with the company, or we want to sell something for certain specific uses, because we're really more consumer facing.
Yes,
I'm not a manufacturer.
like Tom is an entrepreneur and he is an innovator. And he never shuts his mind off when new ideas come to him.
Right,
And if there's a need that's presented,
right.
we'll entertain it.
Yeah, exactly, right?
Well, anyway, so it's that.
Do some evaluation
I
and come up with
that
an interesting
here.
solution and a means of achieving the goal. We got like funding, so 3D printers and stuff going on too.
It's good to know about Chapel.
R&D, absolutely.
I was going to anyway.
We are.
I'd meant to.
He's a busy guy. As far as
Well, as if I have. Yeah.
You can actively, and you got something on.
It's a little aged.
Just a second.
No, I think that's good.
You know.
This is refilling
It's fine.
what I'm familiar with and just
No, it's good.
more detail again. It's like, okay.
Right, right. And you get to hear a little bit more about how we are using it clinically. and so.
Yeah. I've never met Martin before yet.
Interface.
It's great to hear him. I heard and I've been following some of the stuff there and we'd like to get more studies and things going on and as well in the clinical setting. So I'm very open at many avenues
Into this,
to move forward,
into this talk.
learn about
Slides that.
that are being created as well as stuff.
Right. Right.
On
great.
grade. And the easy thing.
Make any more.
Well,
Thanks,
now,
Mark.
but
Appreciate it.
I'll be around.
Okay.
Today.
Ron puts the company like ratings,
Yeah, yeah.
So, yeah. I got a trademark because they were, of course, fighting it. So, are they on time?
Yeah, another minute and.
They got another minute. Oh, no, I have to do-
Hi, everyone. We'll get started in a minute.
After they. One.
Yeah.
It's just.
Yes, there's a recording happening of this presentation that you'll have access to, Patricia.
I'm really not. Had I had a 5-minute conversation. 5 minutes.
Yeah, but you always end up with that afterwards.
That's the problem. I'm great on. Anyway,
That which doesn't kill us makes us stronger.
yeah, let's rock and roll. Wow, almost everybody came back.
Of course,
It's a good sign.
Retention,
it's good. We're interested.
retention.
So how is Len Oaks doing? I did Len's training.
He has left.
Has he left the planet? Okay, I didn't realize that. When did he leave the planet? More than a year ago? Okay. Yeah, I did training with him, I think 2015.
Oh, yeah,
Yeah.
so I wrote the first lens training.
Did you?
In 1997.
I have it, I have that.
You have the mention, yeah.
It's like it's like a paper copy and, yeah, wow.
Yeah,
Wow.
it was, yeah, I knew right away. As soon as I saw what it was doing. Okay,
Yeah,
this fits, I'll explain more.
yeah.
All right, let's get started. Welcome back. Everyone, so I was speaking about looking at individual alpha peak frequency, and which is fashionable these days. So in some RTMS studies, it was shown that if you stimulate the brain close to the peak alpha frequency, then you get better outcomes. So that's what that study is. If you look at the individual alpha peak frequency in the first setting, let's see here. Let me see what those are. 1 second. Percentage change. Okay. Yeah.
A lot of dots.
Yeah, I'm trying to figure it out. Okay. Well, actually, I'm forgetting the actual graph here, but the idea was that if you actually stimulate the brain close to the peak alpha frequency, you get better percentage change in your outcome. And that was the idea behind that study. Let's see here. And so the idea is that, yeah, we start looking at the cue, we can start to change the way, we can start to customize the treatment for people. That was the idea. But let's look at cognitive decline more detail, and then how we might apply the TPBM to that. So you want to talk about this?
You like this one.
Oh, okay.
Good.
So so this is a study done on activating microglia with 1070 nanometers light, which attenuates the plaque burden and improves cognition in an Alzheimer's disease mouse model. And basically, they treated the mice with 10 hertz as well as 40 hertz of 1070 nanometers light, and they showed improvements in various indices, including a maze task and a discrimination task. And if you look at the results, you can also see that if you look at the first one, that's a discrimination task, and you'll see that there's a better outcome with the 10 hertz than the 40 hertz. With the second task, there's this measuring the speed or the velocity of the mice traveling, and they showed improvement in both 10 hertz and 40 hertz. Let's see.
Well, it replicates the original study back from 2006 that Shizou did at Durham University. This is kind of a replication to some degree, although they were looking at the microglial activation. But it basically supports everything that they found back when Shizou and Grillo and Emser did their study at Durham.
This is done in China?
Yes.
Yeah, it's all those Chinese.
And so if you look at this, I think that it's easiest to see the results if you look at the four circles, which is the maze. And you can see the Alzheimer's disease shows the sort of the general path of the mice. And if you look at the distance traveled, and then the 40 hertz stimulation shows the path, and the 10 hertz stimulation shows the path. And so you can see that there's a general reduction that's happening over time. With the different stimulation. Okay.
So this is the study that I did with the folks at Texas A&M, Baylor Scott and White Hospital, and the Department of Neurosurgery with Jason Wang and Damir Smutinov. And they recruited 60 subjects. And there are two studies, and this was the main study that we showed that mini mental status scores changed when people did 6 minutes of the 1070 nanometer stimulation twice a day, and the subjects took the device home. So they were instructed how to do it. They were evaluated with a QEEG and full neuropsych battery, and then sent home with the instructions, and the staff checked up on them in terms of their compliance. And it was remarkable how good the compliance was. We were really pleased. But what we can see here is that there was a significant improvement in the mini mental status exam for the active group, and there wasn't much of a change for the control group. And I mean significant in like 4.8 points, which was significant at 0.05. Yeah. Continuous 1070. Oh yeah. The whole pulsing business is what I had to add, because they weren't into that. They wanted to just shine a light. They wanted to stick a lamp on your head. Sanjay, the battery. We're having a little moment of battery deficiency. But the study was remarkable for a number of reasons. One of which was that because of the way Baylor Scott and White was structured, the neurosurgery department was on the 3rd floor and the regional movement disorders clinic was on the 2nd floor. So they knew they had 3,000 people, patients in a database, and they went downstairs and they just asked, they queried for dementia, but they were querying for dementia in a movement disorders clinic. So what they got were people duly diagnosed with dementia and Parkinson's. That was a fortuitous accident because in the exit interviews after the study, the family and the subject were then asked, what was it like? And the subjects with Parkinson's started saying things like, well, I could move better and I felt better. And then the family members like, are you kidding me? Your movement, your gait, your balance, you're more participating in family activities, your mood, your social engagement, your facial masking. And we were like, oh, this works across the board. And that's what I was carrying as an overarching theory, was that what we're doing is intervening in the overall efficiency of the central nervous system. And if, like I was saying before about immune function, that if we're putting gas in the tank, we're going to increase the capacity of the system to correct itself, to do what it knows how to do. And that's what happened. So here's some examples of clock drawing that we use. Yeah. Oh, yeah. Oh, yeah. That was a good idea. Thank you. Yes, hang on. So this is the clock drawing. This is the cool picture. So you can see the difference, right? Everybody clear? A head nod is sufficient. Okay, great. So here's the placebo cue. Here's the active treatment. This is when you're supposed to make a noise. Yeah, okay, thank you. So again, this is another kind of sub comment. Notice that the power was the most solidly impacted and that the coherence remains a significant issue, especially hypocoherence. So I'm positing and would like people to do the research, to be able to look at what happens when you use photobiomodulation to affect coherence while you're also doing coherence training. And I'm betting, a theoretical nickel that we're going to see significant change. So people familiar with Dale Bredesen and end of Alzheimer's program. So Bredesen has been a pioneer in using non-drug, non-invasive treatment models for the reversal of cognitive decline or dementia of all sorts. So what he did in his original book was he came up with the 36 holes in the roof, which were the different factors that he could understand and could see in the literature that would have a direct impact on cognitive decline, on dementia. So all of these factors, I'm certainly not going to get into it, but the slides are available for anybody who wants them. But the point I was trying to make here is Dale's got 36. We actually went and kept looking and we came up with 45, right? And what you can see is that on the right side, it's showing the peer-reviewed publication demonstrating the positive impact on that factor by photobiomodulation. And you can see that there's only one blank on that page, and there are no blanks on this page. Let's go on. This is a study on vasculopathy and, showing that there's really a point to using photobiomodulation to intervene in all kinds of neurovascular disorders. And one of the things that Sanjay mentioned before was the impact on vascular tissue, because 1070 has a direct impact on increasing the endothelial flexibility. So the actual tensile flexibility of the blood vessel can increase up to 20 microns as a result of being exposed to 1070 ppm. Well, that's going to mean that the pipe is bigger, and now you're talking about increasing cortical perfusion, which is one of the two main causative factors in all neurodegeneration. So it all boils down to two things: lack of blood flow and inflammation. If you can do something non-invasive, non-pharmacological with a zero side effect profile, and you can significantly impact both of those, sounds like a good thing to me.
Okay. All right. So this is a diagram from a study that looked at blood perfusion and their correspondence with different EEG frequency power. So you have these various bands, the 4 to 8, 6 to 12, 12 to 15, and 16 plus hertz. And you see that basically in the alpha band, which is in the middle here, right here, the blood perfusion is lowest. So the blood perfusion goes up in the delta band, drops in the alpha band, and then starts to go up with beta until it gets to the high beta band and it drops a bit. So, it could be partly just related with alpha being like an idle frequency in the brain where less blood is actually required. We see that in dementia, there's basically a lower brain volume and a lower basically cerebral blood flow in elderly versus younger subjects. And if you compare same age normal subjects, people with dementia have a lower blood flow. So as you age, cerebral blood flow tends to decrease with aging. But also if you have dementia patients have lower blood flow than non-dementia patients of the same age. So we see in the terms of perfusion characteristics in MCI, increase in delta and theta power and decrease in high frequency power. So we talked about that. There's basically more slow wave activity and lower blood flow. So theta and alpha in general are related to lower blood flow in the brain. And we have increased theta and alpha power in the brain happening. So one of the ideas is that certainly we have lower metabolic activity in MCI, and the mitochondrial in particular affected, and there's decrease in blood perfusion in the brain. So when you apply light, what happens? We have increased blood perfusion, increased blood flow, increased metabolic activity. So we're directly impacting some of the tissue features in dementia and cognitive impairment. And again, looking at peak frequency value, thank you. We have, if you look at Alzheimer's disease, elderly and elderly young, what do we see here in the gamma dominant peak frequency? So the dominant peak frequency of gamma in healthy young adults is higher than in healthy elderly. And then in elderly people with Alzheimer's disease, there's like a real spread. You can see the gamma just spreading out, and the dominant peak frequency gets lower. So we want to encourage high frequency activity in the brain. Does that make sense? Yeah. Okay, so a couple of studies. This is a study done by Anita Saltmarsh in 2017, with just 5 participants for 12 weeks doing a 10 hertz stim daily with the Neuro Alpha from V-Light. And it reported increased function, better sleep, reduced anxiety, and fewer angry outbursts. And in this study. So a study by Reza, also associated with V-Light, is a single case study of doing 6 days a week of 40 hertz stimulation with the Neuro Gamma. And it shows an overall increase in beta and gamma as the weeks go by. And in fact, there's a, showing a quick gamma increase on the first day, but not so much in the coming weeks, but then increasing over time, actually after 9 weeks. So I'm going to pause for a moment, talk about 40 hertz. So this is the research from the MIT lab of, this, basically what they did was to have uh, mice bred to have Alzheimer's. And what they did was they flashed the light in their cages 40 times a second. And then they sacrificed the mice the next day and discovered that they had improvement in the sense that the plaque volume was lower. And it only worked for 40 hertz, not for other frequencies. So something magical about that frequency. And then they concluded later that, basically the microglia are being activated at 40 hertz. And the lymphatic system is being activated to clear out toxicity, and general garbage collection activities of the brain are being enhanced at 40 hertz. Then they did further studies showing that 40 hertz tones, audio tones, also stimulated plaque reduction, and in this case, more in the auditory cortex and the hippocampus, which is more impacted by auditory tones. Yes. Yeah, I know. Here's the funny thing.
I can give you an answer
Okay. All right, go ahead.
in case
Yeah.
the microtubules that we were talking about before. So the capacitance of the microtubules has been observed in a paper that Jack Tazinski did at the University of Alberta. And he showed that the capacitance was storing the electrical current at 39 hertz.
So why not 39 hertz? Yeah.
I use 39
So
and 40 and
I think, probably we might benefit from doing 39, 40, and 41, but it's just
Exactly.
something in that range. Yeah, cover our bases. Now, I want to tell you that I studied a healing system similar to Rife. It's called frequency-specific microcurrent.
yeah.
And it's a very good system. I like the teacher, Karen McMicken. She has a book out called The Resonance Effect. I studied with her. It's basically, she's a chiropractor, teaches, you have to be a licensed practitioner to study with her. And so it's, a lot of physiotherapists, physical therapists, as well as chiropractors and doctors that study that system. And I somehow I got in, I'm licensed as psychotherapist, but I did it. And there's a lot of clinical, not really good studies, a lot of clinical evidence on these frequencies that she uses between 1 and 1,000 hertz. And in that system, 40 hertz is the frequency for reducing inflammation in any tissue in the body. And we studied that system and had that frequency well before the MIT research even came out. Yes. Well, yeah, that's a whole political question, right? It's a paradigm shift.
Yes.
Ever since antibiotics came into vogue, microcurrent therapy was well used in the US in the early 1900s. And then once the antibiotics were discovered, they were so magical. And then some factions of the AMA took over and decided that all natural healing therapies were junk. Basically, they started taking the licenses away of people using microcurrent and other natural healing modalities. And it just ossified itself, the system. Mhm.
So she wouldn't get sued.
Yeah. Well, because you're treating people. Yeah. Yeah.
To protect the therapy.
Yeah. So I think part of it is to protect the therapy. Yeah.
Absolutely.
Yeah. When things get too popular, like LSD and everybody's, what happens? You get a big backlash. Yeah. And people want control,
Well, look what happened to neurofeedback after, we started talking about instant Zen,
Yeah.
right? What happened?
So, yeah, so something about 40 hertz definitely seems special. So there is actually a study she did on combining 40 and 10 for fibromyalgia. And I have done that treatment on, patients as a therapist come in or neurotherapist, they're having fibromyalgia pain and you're trying to do biofeedback with them. I'm like, okay, let me hook you up to 40 and 10 and it's just microcurrent and see what happens. And they're like, oh, I feel so much better. And they did a study with, 60 people coming to her clinic who'd gone to every therapy under the sun, and she hooked them up. in 45 minutes, their pain went away. And she actually realized that it also had to do with them having cervical trauma, that certain kinds of fibromyalgia did not come from cervical trauma, and it was not cured by that particular treatment. But that treatment actually, 10 hertz in that system is the frequency of the spinal cord. And then combining 40 and 10 in that system reduces inflammation dramatically in the spinal cord. Now, how many people do we treat, and how many, who have concussions for car injuries and all sorts of things that also have injury in the neck? And 40 and 10 is an awesome combination. So that's one reason I like 40 and 10, even for the helmet. Yes.
Is there implication in here before you're?
Yes. Yeah, there's certainly a stimulation implication. Yeah. Yeah. So and guess what? Belite has also discovered, just without knowing all this, that their headsets run at 40 and 10, and there's not an accident. And that's what they promote as, a beginning treatment for all problems. And that's what we also promote, doing 40 and 10 as a beginning, but then you can go much further, as we'll talk. Yeah. Okay, so iMedisync also now, of course, has a PBM helmet with 19 channels of EEG along with it. And so they've been doing not closed loop, which they could do, stimulation, but QEEG guided TPM. So they have a study that they've talked about of for Alzheimer's disease and MCI, which aims to decrease theta power, increase alpha and beta power, and the peak frequency of their patients, of their populations. So they had 53 subjects. They treated them for 10 minutes with the headset 3 times a week for 8 weeks. And they looked at, the QEEGs to guide it a little better. So customize it for them. And they showed that they did some measurements on some measures of the clinical dementia rating scale, that they had substantial decreases in the clinical dementia rating scale for their patients on average.
I don't think they published QEEG, did
No, it's not really published, I think, at the moment. Yeah, it's not published. So this is just showing 9 patients, and so I don't know that they did everybody. So this is just showing a 9 patient of the cohort, and so they showed that typical aging pattern, alpha peak frequency decrease, and when they actually treated them, there was an alpha peak frequency increase. So their recommendation was, if alpha power is low, use 10 hertz stimulation, 14 hertz stimulation, and 40 hertz stimulation. That's what they did. And if alpha peak frequency is low, use peak frequency plus 1 hertz, 14 hertz, and 40 hertz. And if theta is high, use 10 hertz beta frequencies and 40 hertz.
Can you hold that slide for 1 second? Sorry.
Can you ask for the slide deck when we're done? I think so.
Well, we didn't upload them. We were supposed to. So our recommendation, wait, there should be another slide. Oh, this is not this is the old deck. Okay. Well, let me talk about our recommendations. I think I somehow have a different version of this presentation with that information in it, but I like to talk to you about this anyway. So what I've discovered is that stimulating at various beta frequencies along with 10 and 40, just this, what they say in general is most beneficial. And then a new discovery as well. So most people who have these problems have high theta. And certainly you can look at the Q to confirm that. But what I've created, I have a custom protocol that I'm offering people now. It's not preset yet, and I'm going to probably make a preset in the Neuromatrix that basically goes through the beta range and starts with 10 and then goes 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and then 40. So it's just like one inclusive protocol that does 3 minutes each at each frequency. And then you just program it in and give that to the patient and say, okay, just do this daily or 6 days a week, and they get better. You're just giving them all the whole range. Just some like if you're looking for like an easy package for treating this problem, that's like a great custom program that you can do. Now, another thing you can do, you add to that is add some 0 Hz initially to just feed the brain. And you combine that and this in some order and not overstimulate the brain. So you may want to start them slow before they build up to the maximum time of stimulation that I'm talking about. And I'm finding it super effective. And then there's a new discovery which I want to try. I'll talk about that in a minute, but let's pause there for a moment. Yes.
Autism or for what population?
Kind of slowing of the brain, basically. So it's showing, it's showing some mild decline or some starting dementia. Yeah. Yeah.
Is there that?
Not for you, typically. Okay. Not for you. Okay.
But well, I'm pretty slow right now. Ooh. But I wanted to ask about the beta reset protocol that was popular at.
Yeah, it was like 10 years ago. It was popular at ISNR.
I was wondering if this has the effect on hyper coherence, which it does.
This goes.
Yeah.
We can do a simple exercise later when we're done about diagnosing that issue. But how many people are familiar with glykinesiology? Muscle testing? Okay, well, there's a way to assess coherence issues using applied kinesiology. But what we're finding, and I've been finding this since the very beginning, is that as you increase the level of dysregulation, what you're going to see in the EEG, if you just use the dominant frequency, what you're going to see is a restriction in the dominant frequency range, the absolute range, and the variability within the range, right? So that as character pathology is the term I would use from a psychodynamic point of view, but as the system becomes more and more dysregulated, the capacity to differentiate more and more, finally discriminate between similar and different. That's what we're talking about. And so the capacity to finally discriminate between similarities and differences diminishes. And from a general systems theory point of view, you guys can't see me yet. From a general systems theory point of view, what we're talking about is that principle of isomorphy. When something is isomorphic, you can observe the principle at every level of abstraction in the system, right? Isomorphic. And so that's the cocktail party word. So you want to understand that when we're talking about expansion and contraction, that's an isomorphic principle that's observable at every level of abstraction in the system. So at the neuromuscular level, when we talk about the ACE score going up, we're going to see in what Frank talked about the other day, right? It's all the same thing, that deep brain trauma causes a contraction in the system, right? And that systemic response that I'm doing, right, that has an EEG correlate. And the EEG correlate is the restriction in the dominant frequency range and variability. Okay. Now, this is reality according to Marvin, but I think it's pretty close. So we want to look at that dominant frequency behavior, and what we'll see is that there's a corresponding pattern of bilateral hyper and hypocoherence. And that treatment then becomes what we can do with the neuromatrix, right? What we can do is differentiate based on where we see the maximum dysregulation in the coherence. We can then set the parameter just below and just above that range and put one end on one side and one end on the other, stimulate that way, and then flip it around and flip it around and flip it around and flip it around. So what we're doing is recreating the capacity for bilateral processing. Did you do what you wanted to do?
Yeah, so I typed in my recommendations and you know, this is evolving. So the other part that, so you may want to, you know, you need to split this treatment up into 2 parts during the day, typically. Mhm. So you can do this in your custom programs in the Neuromatrix. So the other thing that Marvin's talking about is affecting the coherence by programming the quadrants differently on the left and the right. So that program is, that slide is not here, and actually he has done it and I haven't done it with my clients yet. So we're going to start, I'm going to start doing that as well. So we're going to play with that and we'll give you those recommendations if we're consulting with you as to, you know, just flipping the sides to affect the coherence, especially if you notice that is needed by the QEEG. Mhm. Yes.
These recommendations.
This is for cognitive decline and slowing of the brain. Oh.
Slide that you had before?
It's their recommendations.
iMedisync.
That was iMedisync recommendation. This is my recommendation.
We should have made the colors different.
Mhm. Mhm.
So do you recommend, so you don't recommend following what they said?
Well, what I recommend is, this is close to what they're recommending, by the way. It's not that different. It's just, what they said was if theta power is high, then use 10 hertz, 40 hertz, and beta frequencies. That's what they said. I'm telling you, use 0 hertz to get started, and then do 10, 11, and 12 hertz. This is going to affect the peak frequency. You know, this is a peak frequency recommendation. And then use the beta frequencies, which is 40. I'm giving you a more specific recommendation. And then use 40 hertz. So it's not that different.
Low or high?
Yeah, I'm saying you can use this as a general formula. That's what I'm saying. Yeah. Mhm. Yeah.
It's more granular in a sense, and the granularity relates to the reinforcing of a more variable, of an increased variation within, say, dominant frequency or the overall, you know, response in the CNS.
Mhm.
Because what we want is to increase the capacity for adaptive response, right? And so increasing the capacity to discriminate between differences in the apparently similar and similarities in the apparently different, that dynamic is what we're doing with everything that we're doing. So the capacity to more finely and finely discriminate between similarities and differences at the level of the EEG is to create a more finely adaptive, you know, response capacity.
And that's why adding frequencies to the photobiomodulation is powerful. And sometimes the argument becomes all about power, and which is a mistake, in my opinion. For example, we'll see in the stroke studies later that the stroke studies showed reduced infarct size on animals and even with people initially, but then later the stroke study had to be stopped because it wasn't showing clear results, and the company had to fold it basically. But what they were doing was just one treatment with a high intensity power laser, and it was not sufficient to do one treatment, and also no frequency was being used. And then they still discovered later that they had more significant effects in the cortical parts of the brain, if the stroke was in the cortical parts of the brain, than if it was in the subcortical parts of the brain because of penetration issues. However, power is related to penetration. However, when you add pulsing to it, you get a whole other power that affects the brain. And that's why we can get away with low power and, get clear clinical effects by using different frequencies, because the resonance effects in the tissues amplify the effects, basically. The resonance amplifies the effects. So your low power, you can do low power, but the resonance will then amplify the effects of the low power. Does that make sense?
Yeah. And in terms of amplifying power, wait a minute, Cindy, amplifying power, we're talking about delivery of light in a concave structure. So you know what constructive interference is? When the lights land on the photons land on top of each other, it means that they're going to penetrate deeper. So the fact that you're remember using the magnifying glass to set the light leaves on fire? Am I the only pyro? Okay, anyway. You know what I mean, or no bugs. So using the concave structure is going to then hone and focus the light even more, right? And get it more powerfully deepening in the penetration. And that's why I was very interested in doing this, because again, the Cognito light had this capability, right? But it also had fans all over it because it was that powerful.
I believe I found a paper in which they actually tried to somebody calculated this as a simulation to how much increase of power you could get by focusing, but I haven't, it's not in the slides yet. I have to look it up and make sure it's correct and put it in there. But it wasn't a real measurement, but it was a simulation, a mathematical simulation. Yes.
So. I know you did.
Yeah, this is over the whole brain. Yeah. You know, that's a good point, because I have actually tried it in different ways. So you could definitely, I have done a bunch of protocols with people recently where I've done higher frequencies in the front and just stayed with the lower frequencies at the back. And so just program the higher beta frequencies and go from 10 to 14 in the back and just keep repeating that. So you would do like, 20, 20, 20 in the front, and then go 10, 10 at the back, and then 22, 22 in the front, and then 11, 11 at the back. Yeah. And so on. And then 20, yeah.
What
Yeah.
programmable means.
Yes, exactly.
There you go. There you go.
Yes.
Just that I'm lazy and I really love neurofeedback, but the paste and the computers and I use the helmet instead of neurofeedback. It's like, oh, I need some more focus, I'll do that. Oh, I need to chill out. Oh, it's time to sleep. My head's spinning, do the sleep protocol. It works.
Yeah.
This is not the great replacement theory.
No, I'm sure the additive, there's places where, yeah, and you're gonna get to that.
Well, the goal, like I said before, right? The closed loop is the goal, right? So that we're then using the data and then using the light to affect the kind of change that we want to see in the cue.
I have a question about working with dementia patients or clients. So if it's like ADHD or brain injury or whatever, then
Compliance?
no, I'm thinking the client is coming in with goals, but with someone who has Alzheimer's and the family's coming in with a Alzheimer's patient, what do you present as the goal? That you're slowing down cognitive?
Slow, stop, reverse. The question is, where are you in the process?
Just repeat what was the question.
The question was having to do with what do you do? What do you set as goals? What can the expectations of somebody with dementia and their caregiver be? So one of the things that I've said all along is that we're dealing with a system, the caregiver client patient system, right? The loved one and the caregiver. So really the treatment model is for both. So that's why the original design was that there are two programs being set independently, one for the person and one for the caregiver. So I encourage people to do a cue as a caregiver as well as the person to get the system effect, and also to make sure that the person is getting the support that they need, because I think we all know that it's the caregivers who are dropping dead before the people with dementia, right? So that's a fact. Right? So we need to, in many, many cases, so we need to take care of both. So I said that we offer, based on the data, that depending on the severity of the symptoms and the systemic effects and everything else that goes into why somebody has dementia in the first place, the 45 different things that could be going on, we then say, okay, we definitely know that we can affect a slowing of the progression, so we can change the slope of decline. We may even be able to stop certain aspects of decline. And in some cases, we have now shown and published on the fact that we have significantly reversed the disease process, right? Not just the cognitive functioning, but the disease process in fact. So you see the p-tau levels dropping, the A-beta 40 and 42 levels dropping, the heat shock proteins changing, the cytokine functions changing. All of those biological markers are changing, right, in the right direction. So, okay. Got it. Yeah. Define your terms. Yes. Keep going. Yes. Okay. Keep going.
Study though.
Are you saying longitudinal data or my experience of clinical experience?
You think
Continue to use the data set or like this,
Vitamin, it's not an antibiotic.
so they use it.
Forever. Right. And why wouldn't we? Right? That's the other thing. So it stops becoming, oh, do I have to? It's like, well, I brush my teeth, I have my coffee and I do my homework.
Yeah, so what he said was in his experience, but we don't really have studies for
How could we?
5 years.
Right? How long has this been on the market?
Yeah, it's definitely happening, trying to happen. Yes.
Is it possible that it would work by using it less frequently?
Yes.
Yes, certainly for younger people. Depends on how bad your metabolic issue is. I've used the helmet a lot and I use it much less. And, so it is less need for it. And certainly like this, just before the talk, I was sitting there an hour before, I'm like, I'm just finding it really hard to focus. And I just put on the bright mind and I was substantially better. And then 2 people came over, they wanted to try it. So otherwise they would have done focus as well. It made a clear difference.
Okay.
It was dramatic, the difference in a challenging situation. Yeah.
I'm 18 years sober. I've been using, I mean that seriously. I've been using it for 18 years. So, but I've been using the Cognitolite and the Neuradiant tricks. So I can certainly attest to the fact that there's long-term benefit. That yesterday, my the 10.2. What was the 10.2?
What was that?
Is that my peak alpha?
Yeah.
Yeah.
His peak alpha was 10.2, which is really good. Peak frequency alpha. Yeah. So I'll tell you another story about that. Yes, go ahead. Yes. That's for you.
The biomarkers we use the QEEG, we use the brain mapping, we use we use blood and serum analysis for the other measures, but I wasn't involved in those things because those were studies done at Durham University. So the biomarkers that are measured using standard, procedures for gaining, in tau set 217. Usually they're all serum measures for the most part.
They do not involve sacrificing anyone.
No.
Just joking.
No.
All right.
Just blood or pee or, by the way, I tend to use breaths per minute, and I would certainly encourage everyone to start with a biomarker of the people take a minute. And whether their respiration pattern, I mean, this is biofeedback 101, but definitely using that as a metric for the people, especially people with, dementia and stuff like that. How many times do you breathe in a minute? And they come in the next week and you sit there for a minute and count the number of breaths. Oh, look, you're not breathing 22 times a minute. Now you're breathing 16 times a minute and you're not dead. What do you make of that? Right? And they laugh and we just go on. But what we're seeing is exactly what we want to see. Right? So. With being a human on the planet, you want to go for less breaths per minute. Well,
They're supposed
Paul-
to be a resonant
yeah,
frequency.
RSA biofeedback and Paul Lehr's work at UMDNJ was 6. He said you'll harmonize all the physiological systems in your body if you're breathing 6 times a minute.
Or whatever, right?
No, that's life. No, that's life. Yeah. In life, 6 breaths a minute. I'm not kidding.
There is a general trend with slower breathing and even deeper states of meditation,
Right.
relaxation, functioning. And, the idea that there is a lower number of breaths per minute that produces a resonant HRV response
Yep.
in people, which is around that, but can vary for people. Mhm.
It's higher in children.
Yeah, it would be. Yeah.
If you go back to the ACE questionnaire, you definitely see a correlation between hyperventilation and ACE score.
So here's a little anecdote. So I have a friend, his father was 90, he's 90 plus now, and he's a wealth manager doing well, and then, losing brain function and being in a home with his wife. And then he basically said that now I really can't function very well anymore. I'm ready to go, to do some, inject some morphine, let me go. And they could see that they were willing to do that. So they were having a family meeting about that, like letting him go, because that was his express wish and they wanted to honor it. So he was telling me that, and I was saying, and I told him, hey, I've been working with this headset. Why don't you try it? Could help him. I mean, if you want to, if you're not sure what to do, you want to keep him around, it's well worth a try. So he talked with his family about that. They were like almost ready to decide to pull the plug, really. And so he took the headset from me. I said, give me a couple of weeks at least. So 2 weeks later, his father reports he's starting to feel better. And 4 weeks later, he's changed his mind and he's still here. This was like a year and a half ago, a year plus. I'm looking at somewhere around that range. And I just went and saw him last week. We just made some changes in his programming. And what my friend didn't really talk to me in detail about the programming. So I told him to do the 10, 40, and the beta frequencies basically. And he set him up to do an hour and a half a day. Says, so just watch TV and just keep doing it. And for whatever reason, he wasn't, like, his body was slow enough or whatever. He wasn't overdosing. And anyway, now they inform me that I think he probably just ended up doing an hour because it has to do with, your willingness, how much compliance. But he was willing to comply to a great degree. And anyway, now he's telling me that the family thinks that he's actually sharper than he was years ago, some years ago, after being on the treatment for, more than 8 months. So, you definitely have stories like that. And we definitely use a protocol similar to what I'm suggesting. And I am now making some improvements by doing more, higher frequencies in the front and lower ones at the back. The other thing that I wanted to mention, and you have access to this, if you get the helmet and you talk to us, you get supervision with us, some free and then later paid, and also a group. We have a research group in which I post these protocols. I also do a free meeting every Wednesday at 12 p.m. Pacific time, where anybody can come in and discuss what's going on with your practice and with the helmet, or any other fun issues we like to talk about. And then the other thing that I'm looking at now, which I want to show you a little bit, as well. I'm going to pause here, I think, for a moment in this presentation. One moment. Let me click in here.
The same person on Zoom that asked about biomarkers is asking, when you use blood work for getting some of the biomarkers, do you have a nurse on staff or work with the physician's office?
Just repeat it for the Zoom. Come here.
The biomarkers that are collected in the context of a formal research protocol that's IRB approved. So they're done in a hospital setting has been what we've been doing so far. So this is, it's not, I don't take blood samples. You know, I do the QEEG, I do the breaths per minute, I don't do blood work.
Okay.
Question.
Yeah, licensing.
Good question.
So this is, I just wanted to share a few slides from Julia Scott, who
Oh, right.
graduated from, you know, the University of Santa Cruz, UCSC. And she did a study with the neuronic. Yes. Oh, thank you. I'm so glad you're here to remind us. Okay, where did it go? Here.
Yeah.
Okay, here we are. Okay, so this is a study by Julia Scott and her students, and Marvin's on there.
That's at Santa Clara University.
Santa Clara? No. Okay, not Santa Cruz, Santa Clara. Okay. All right. And looking at, you know, how is EEG affected by different stimulation protocols in TPVM. We'll keep going on this. And so basically the idea was to do EEG measures, pre-stimulation, do a stimulation for 5 minutes, measure EEG for 1 minute inactive, stimulate for 5 minutes, measure EEG, stimulate again and measure EEG. And do a post for 5 minute EEG measurement for 5 minutes. And look at different stimulations. So different simulations were tried. I actually you don't have to go through all of those. And these are maps, topo maps for something that she thought was basically the same. It should be a no, you know, not do much in the sense of it should be like 0 hertz. So she calls it proxy continuous stimulation. She was just trying to see, you know, if you can, what happens if you do something that's pulsing, but is close to continuous. And it turns out she was using 1,000 hertz, okay? So this is pulsing 1,000 times a second, okay? And if you look here, what do you see? Pre-stimulation to the first period of inactive. What happens? There's a drop in power in basically all the frequencies. Do you see that? Right? And then what happens at the next period of it, after 5 more minutes of stimulation? There's a rebound because the brain is a dynamic system, right? Do you see that? So there's like a drop of theta here, and then there's a rebound, but not all the way to the back. So this was very red, high theta, less red, and then more red, but not as much as the original. And similarly in alpha, similarly in beta, you know, there's like a rebound, and then theta, there's a heavy rebound and some increase. And then at the end, it's, you know, there's a general decrease, except in theta, except in gamma. Okay. So I'll show you that in the next graph, actually.
And this is what she called nothing happened.
And she's reporting that, oh, basically the helmet didn't do anything. I'm like, wait a minute. Okay. All right. So but this is only a pilot study with, I think maybe she's looking at one subject or something, but still, and this is consistent with what I find. That's the reason I'm putting it up. And we're going to measure more data on this. And I'll tell you more about why I'm using very high frequencies now. Okay. So this is the proxy continuous stimulation, 1,000 hertz. steep drop in theta, drop in alpha, and then a rebound of theta, a real rebound of alpha, and then a drop. And beta was low, but it basically got even lower. And then the 10 hertz simulation was actually unclear. So there were some issues like, okay, the 10 hertz, not so clear, but you'll see that even that has other things that happen that are not, that are shown in her own data later. Okay, so this is a metric she calls a high-low frequency metric, the ratio of high to low frequencies. And you see that when you do 10 hertz stimulation, what's happening to this metric? That's 10 hertz stimulation pulsed for this subject. The high frequency metric drops, which means there's less high frequency, rebounds, and then drops repeatedly. So what's happening? Basically, when you're doing 10 hertz stimulation, you're getting more low frequency activity in the brain. And it's a significant change, right? And which is what we want. Okay, and we can actually, this is more complicated. This is just doing the back. So we'll just, no, actually, wait, that's not correct. Okay, so this is looking at just the alpha at the back of the head. That's what this yellow line is. The posterior energy of alpha, okay? So you see what's happening in continuous stimulation, the posterior alpha is going up. And with time. And if you look at 10 hertz alpha, it jumps up, goes back, and then actually crashes a little bit to the lower than the original. So it's not like all linear in the sense that you do 10 hertz for 15 minutes, it all increases alpha at the end of 15 minutes. It can go up and down because you're affecting the alpha. That's what you're doing. And sometimes even increasing the alpha, that will cause the brain to drop the alpha temporarily. Then the question is, what happens 30 minutes later? That's not been measured here yet. So that's important, actually. Yeah. Okay, so if you look at 1,000 hertz, you notice, okay, so at the back, there's a real drop. Okay, well, this gets more complicated. We'll go on. So anyway, I'm going to stop that. And the reason I brought that up is that I'm going to talk more about my meditation protocol, which uses 1,000 hertz and 2,000 hertz, etc. And what I realized what that does is to produce a mini psychedelic effect. So it's like a cyberdelic. What happens in psychedelic studies is that not all, but some of the psychedelics show a steep drop in the power on the usual frequency bands of alpha and theta and beta. That the power in the bands we usually correspond to a usual functioning state drops rapidly, that allows us to go into an altered state. And that's what 1,000 hertz is doing. It's crashing the power in the low bands and increasing the gamma power. And the higher gamma power is associated with, higher sensory clarity. That's why when you do the headset and you look at the world, things look sharper. That's actually a high frequency effect. And it's because the sensory cortices run at higher gamma frequencies. And then their activity is suppressed by the usual default mode network, alpha, theta, and beta activity. So we're suppressing that activity, increasing the sensory resolution of the brain and just getting more present without less in the thinking and creation of a self mode.
There's another piece.
So will 1,000 hertz then the question arises, will doing 1,000 hertz help mild, cognitive decline and dementia? And the answer is likely yes. And the truth is I haven't really done it yet. So stay tuned. Because why? We want to crash the theta in mild cognitive decline, right? And we want to reorganize the system. We're going to give them a mini psychedelic reorganization experience without giving them a psychedelic. And then see what happens. We don't want to overdo it. You see, that's another thing. We don't want to do this every day. So this is all part of the learning process of, working with this. And I'll say more about it. You wanted to say something?
When I first started working with Cognitolite, one of the things that I was doing was having people go to the door. I had a full glass door. And I said, look out the window and look at the grass in front of the office, look at the bushes, look at the tree right by the end of the block. Now look across the street at the trees in the park. Got it? Okay, come on. And they'd sit down and we do a 6-minute session. Okay, go back, go look out the window and give me 3 adjectives. That's all I ever said. They'd look and they'd go, wow, brighter. Huh. Yeah, the colors are more vivid. Yeah. You know, I can see the leaves on the trees across the street, and before it was just a green blur. I've done that with 3,000, 3,500. I mean, in 18 years, you know, I've stuck it on a lot of people's heads. 90% of the people give me those 3 adjectives. Now, we did not change the shape of their eyeball in 6 minutes, right? So what happened that makes any kind of sense? And I think this idea of cortical perfusion has something to do with it. I think it also has to do with the idea of increasing the throughput capacity for information transfer from the retina to the occipital lobe. And so what they're getting is the capacity increase to process more visual data. And I, you know, have done this many, many, many times, and it's been a very consistent response. So I offer that as, again, additional, you know, observation about what's possible.
So what's interesting here is that Marvin is talking about just using, 0 hertz, basically. So 0 hertz itself, increasing the efficiency of processing in the brain, increasing throughput, increasing blood flow, increasing sensory clarity. And then what I'm adding to that is if you're doing something like high gamma stimulation, we're adding another factor that will increase the sensory clarity by basically shutting down the thinking of the brain. So that's like a whole other factor. So there are 2 factors at operation here, the frequency factor and the light factor. Yeah. So yeah, so really when you stack them, you get a very powerful device. All right, let's continue. Okay, so share.
No more questions from the netherworld?
I have a question.
Oh, good.
Promoting this device, like advertising it for help with cognitive decline.
Don't say it cures anything.
Excuse me?
Don't say it cures anything.
Say it improves cognitive ability or
Yeah.
cognitive.
Brain health and wellness will probably not get you the black helicopter.
But if I mention like a cure, treatment.
You use the C word ever.
Yeah.
That never
Or
use the
treatment,
C word.
Or not even treatment.
I wouldn't. Especially in this climate.
Promotes brain wellness no matter where your brain is.
Yeah, peak performance.
Yeah.
Brain wellness. Yeah.
Here's another little miracle story, you know. Roger Lee is a clinical psychologist in Hong Kong, and Roger's been working with autistic and developmentally disabled kids for many years. He's doing his dissertation now on photobiomodulation and autism. And Roger and I started working together. I trained him on photobiomodulation, and we worked together. And Roger then took a couple of his clients, children, and one of them was this little boy who was very disabled and had done a year of SW Loretta neurofeedback, like twice a week. And he then did these couple of sessions, 4 sessions of photobiomodulation using a 10 hertz pulse at 25% duty cycle. So duty cycle is the percentage of time that the light is on during the on phase of the pulse. So you can be 25, 50, 75, or on continuously. So this is at the lowest possible setting. We did 4 sessions with the neurofeedback and the photobiomodulation. The picture on the left is the one that he drew in school, and the teacher said, "Oh, Johnny, what is that?" And he said, "Oh, that's 3 dragons dancing." And then after the 4 sessions, he said he wanted to draw a picture again. And she said, "Well, what do you want to draw?" And he said, "Oh, I want to draw the 3 dragons." And that's what he drew. And there was no instruction about how to draw anything. There was only, okay, go ahead. Well, and, I think there was a conversation about color selection, and that was it. And he was interacting with the teacher about this verbally in a way that hadn't happened before. And you can see the differences in the QEEG.
So in the headset, the duty cycle is indicated by power bars, and you can do 3 power bars, which is 25%, 50%, 75% duty cycle, and 100% means it's just on continuous. So that's the same as 0 hertz. That's how you can control the fluence, how much delivery you're doing. Most of our protocols are 75%. But you can, like the sleep protocol uses 50% duty cycle, but this was a pretty low delivery of light because I suppose, the child was very sensitive, and combining that with the neurofeedback apparently was very powerful. Yes.
SW Loretta neurofeedback to getting the light. This many.
Wow.
So is that the pre-Q or the post?
Yeah, that's pre. I don't have the post. Alpha. He was wanting to go with the middle range and increasing the relaxation that comes from that, but at extremely low dose of stimulation. Extremely low dose of stimulation, even standing here. Got it?
75%. I don't know why, but so 50%, how does that affect the?
It's less light. It's less
It's
delivery.
less delivery of light per second, basically.
Oh, it's a different part.
Amount.
Yeah.
It's
It's a
amount.
different amount of delivery of light, right? Yeah. So if the light is on only 25% of the time, or 50% of the time, or 75% of the time. Okay. So even though you're flashing 10 times a second, within each second, it's only on for less time. So it's only on for half the second.
Okay.
Or 25%.
It's a complicated concept, a duty cycle, yeah.
Duration.
Yeah.
Thank you.
So then we can look at some other conditions and also a meditation protocol. Okay. Do you want to talk about this? Thank you.
This was another where they did 3 sessions of integration before SW Loretta neurofeedback. And this child who had very limited speech and slow response then started being able to point and speak up when the video, what video she wanted to watch. She was able to smile and she was smelling her mother's clothes in public. That really stopped. And scrabbing and rubbing, that really stopped. And the overall responsiveness of the child in terms of, contactfulness with significant others was significant. And it was 14 minutes at 10 hertz with, again, 25, and then the left was on 50. So you had the right at 14, the left, yeah, it's all 14. and 10 hertz. 14 minutes, 10 hertz, 25, and then one.
So you can
period.
see in the queue that the alpha is, alpha power is low for this child.
Okay.
You're aware, was that consecutive, a rest day or?
There was probably at least a day in between.
Sorry, a day in between.
So neurofeedback sessions with photobiomodulation. There was probably more days than, it was at least one day, and it was probably more like 3 or 4.
So in these.
They did the stim and then neurofeedback each session. So it was concurrent. And that's what I'm advocating. That's my position, is that we really want to be doing both. Am I the only one that's tired?
Yeah, I think we're getting to the end here a little bit. So I skipped a few slides, just to point out a few important things and we'll finish up. So just staying with the idea of QEEG, if this is a client that I had, so I'll come back here. So staying with the idea of looking at the QEEG for a moment, this is a client I had with aphasia due to stroke, left-sided stroke. So if you look at the QEEG, what do you notice about how would you start to address it? If you notice, okay, so there's this low power in delta, low power in theta on the left side, low power in alpha on the low power in beta on the left, low power in I beta on the left side. So pretty easy. What's the primary pattern in this EEG? It's left-sided low power, which is likely due to stroke. The brain's not, producing enough oomph. So what did I decide to do? I said, okay, well, let's just stimulate him at all the frequencies. That was my initial plan. That wasn't the final plan, by the way. So that was just my initial idea. Okay, let me play with this. So let's stimulate the left-sided, just go through a sequence 2 minutes each, left front and left rear only. And this is going back to, some of the studies on stroke where you only stimulate the stroke side of the brain, not the opposite. And so I decided to try that. And then, and then maybe just a neurometrics focus protocol in the afternoon, which actually does 18 on the left, 14 on the right front, and 10 at the back. That's the focus protocol, 18 left front, 14 on the right front, and 10 at the back. And then also I had him on alternate days do 0, 40, and 10, because we like 0, 40, and 10, but generally for the brain. So I had him do that, and he had improvement. Oh, wait. And then later I switched to, I changed the protocols around for a bit, just focusing on the higher frequencies for him, and he improved further. And, his speech started to come back. In fact, so his partner brought him, who had brought him in for the original cue, So his partner, when she brought him in for this cue, even before he had been using the helmet for 2 months, without looking at the cue, I hadn't done this protocol with him. I was just doing 0, 10, 40, and some beta frequencies. And they came in with him and her mother, his mother-in-law. And I asked him, so how is it helping? What do you think so far with 2 months without doing a cue yet? What do you think? He said, well, I'm not sure. And the mother-in-law spoke up and said, what are you talking about? You would sit across from me in the restaurant and not be able to speak. And now you can't stop talking. Completely different. But he was not aware. Okay. All right. Yeah, I changed that. I realized it didn't matter. And now what I have him on right now is stimulation with higher frequencies on the left and lower on the right. So like I was saying, on an average brain, just looking at the cue that doesn't need this, we have higher frequencies in the frontal lobe and lower at the back. With him, I have higher on the left and lower, like 10 to 14 on the right. And I have him going all the way from 10 to about 28 on the left. That's what I have him on now. So that's what I decided would work best, is working well for him. Yeah. Yes.
switching from stroke to Parkinsonism? That's, if anything to report on that, because I have an opportunity to work with public.
Let's give me another 2 sentences.
In terms of, one I just met at a Alzheimer's cognitive decline meeting, and with I have neurofeedback that's shown some good efficacy with Parkinsonism, and so it's an opportunity. He's still functioning with the support of his wife, verbal, still a little shuffly in gait.
So you would definitely want to put more gas in the tank. And that's what 0 hertz is, right? So this is someone with a dysregulated system. That means that they're functioning less efficiently. If they're functioning less efficiently, then from the second law, we know that they're burning more calories in order to do the task. So if they're burning more calories to do the task, then they're going to use up the available gas in the tank quicker. Are we good? So if they're using up the gas in the tank quicker, then there's not going to be sufficient resources available to do things that are lower priority, like repair. So what we want to do, and this is where Dirk de Ritter and I came together, and Dirk was talking about how his TDCS and infraslow treatment model worked really well, but then this was at Saybrook, the conference at Saybrook, and he said that everything was going really well. He showed all the differences in brain function. He said, but at about 2 to 3 weeks later, they all crashed. Right? And he said they ran out of gas. And the day before, I had done the presentation on photobiomodulation, and I had talked about how what we're doing is putting more gas in the tank. So when he said everybody might run out of gas, everybody in the room turned and looked at me. And he was like, who the hell is that guy? Right? And that's when I said, I've got your gas station. And we got together, and Dirk is doing research in Belgium using photobiomodulation, and he's doing a clinical trial in New Zealand. But the point was that you've got to put gas in the tank in order to provide resources sufficient so that the system can then do the work, right? And that what we're all doing with neurofeedback and psychotherapy and is we're making therapeutic interventions that are inherently making a demand on an already deficient, functioning, dysregulated system. What's wrong with that picture? Right. So that's what this is really all about for me. It's like, put gas in the tank so that when you put the car in gear, I know it's a guy metaphor, but you put the car in gear, you have the resources to go somewhere. Then you can tune the carburetor.
So in general, you would use 0 hertz and then feedback ideally with the patient. In terms of frequencies, we don't really know what frequencies you would use other than some standard ones, which is 0, 10, 40, and 14. 14 because sensory-motor rhythm, and maybe now I'm starting to look at 1000 hertz, but we haven't tested that. So I would want to test that. That's another option. Okay, so.
Can I do the commercial?
Yeah.
This is a commercial for the foundation's IRB. We keep saying there needs to be a study about that. We don't know that yet. We haven't figured that out yet. What I came this time to say was the Quiet Mind Foundation has its own federal-wide assured institutional review board. That means that we can review any research protocol that's going to use human subjects. And we can approve it so that you can then do the protocol and submit it to for publication, right? Without an IRB approval, no publication, no editor will accept it. So I want the ISNR to now take seriously the fact that we can do studies with people, get an IRB approval from an IRB that literally understands what it is that we're trying to do. Really, no kidding, understands, rather than a university IRB where you've got 2 neurologists and 4 psychiatrists and an occupational therapist and a social worker on the IRB, and they're like, what? So that's not going to happen with us. And that's what I want to do. And we're going to make hopefully the IRB, the board is going to consider this, and we're going to provide discounted pricing for IRB reviews to ISNR members in good standing.
Okay, so maybe just a quick conversation, a couple of things, meditation and long COVID. This is a study, you want to talk about this, a study?
Oh, Praveen Irani and Robert Bowen. Speaking of IRB, the Quiet Mind Foundation IRB approved this research that was done by Bowen and Irani. And what they did was take, the bed, the Thor laser bed, the clamshell thing. So they had one of those and they had Neuradian. And what they did was equalize the photonic delivery for both devices. And what that came to was using 0 hertz, no continuous stimulation with the Neuradian for 14 minutes, and the same thing for the Thor bed. And they got 14 people who were independently diagnosed with long COVID, which meant a minimum of 5 months of symptoms, brain fog, fatigue, all the usual symptoms that go on with long COVID. They were then randomly assigned to one of the 2 conditions. They got QEEG, ERP, and a number of other measures, digit symbol substitution, and a couple of other things. But the point was that they did each treatment 3 times a week for 14 minutes for 1 month. At the end of the month, all 14 people had completely remitted from symptoms. And some people were reporting that they felt better at the end of the month than they had before they got COVID. So these are the measures, but I don't think you can look at these whenever you want, but this is the results for all subject for P300 for the flanker test. This is the IRB data. So you can see it was pretty significant change. So it improved processing speed and power in the subjects with COVID. It was definitely transcranial, whole body, and brain. It was the same effectiveness. And digit symbol substitution was really the best test for evaluating blood for brain fog. And QEEG-RP can be an effective tool for assessing response to treatment in a clinical setting.
Right. So the conclusion of that is that you don't have to buy the helmet, you can just buy the bed. I'm just kidding. Just kidding. Exactly. So I'll just talk a little bit about meditation research. So I did a meditation protocol with the NeuroPro 2. And that's because we started playing around with the NeuroPro when it first came out very early, and really found, interesting effects at, so that's this, okay, what's missing there? That's the current meditation protocol. Let's see, go on. So in general, we realize that as we increase the frequency of stimulation, body energy goes up, body awareness goes down, arousal goes up, and focus goes up approximately. And long-term meditators show high amplitude gamma synchrony during mental practice. This is a study. And I think of the frequency as an index to states of awareness and sense of self. As you go increase the power in the lower range, you get into more body experience, feeling the body, instinct, pre-personal material. Like, alpha theta training, you can access personal material and start to integrate that. As you go higher, you get more into the spiritual, intuitive, and superconscious realms. And in the middle range is where we usually are. So if you want to travel outside, we want to go low and high, outside the usual range, basically. We also have another study with talking about increased gamma brainwave amplitude compared to control in different meditation traditions. We have high frequencies being created by the brain. And I use a coherent phase stimulation in the NeuroPro 2, that is synchronized stimulation. And when you do synchronized frequencies, you actually are, allowing the brain to go into this highly coherent state, and which will improve connection in the brain. But if you maintain that for a while, you actually make it harder to think. You're treating the brain, but you're not able to function as well because it needs a certain level of desynchronization. Especially that's what beta is about. It's desynchronizing the brain. So we found experimenting with meditation teachers is that combination of low and high frequency combinations going both low and high increase the sense of expansion, lightness, perceptual clarity, peace, joy, energy, and cause a reduction in thought. So this goes along with the idea in a mindfulness state, you want to balance calmness with energy. To be in a really present state, you want to be calm, present, not asleep. You want to have equanimity, but you may also be having a lot of pleasure in the body. So if you don't get caught up in the pleasure, then, it's equanimity balances it out. Okay. So we find that high frequency stimulation in general leads to expanded states, expansion of the sense of self, positive feelings, more equanimity, but it can also lead to agitation, dissociation, discomfort, and sleep issues. So we want to create more of a balance by using a high and low combination. So this is a meditation protocol that I used in the study. Oh, this is not actually right. Sorry about that. It's actually the meditation protocol I used is not just 432 hertz, but 1,000 hertz also. 528 hertz, 720 hertz, and 1,000 hertz. This is the wrong study, wrong deck. Let me see if I can find a better one here.
That is the one, isn't it?
That is the one, but I'm not sure what happened. Let's see. Yeah, not quite. Okay. Anyway, I'll find it. Just give me a second. I'll find another one here.
PowerPoint version-itis.
Too many versions.
Any questions?
Okay, found it.
See like any reactivity in some patients.
Dizzy, sleepy, headache, irritable, anxious, congested. Those are the things you want to be teaching people to look out for during the time that they're doing the session, especially if they're doing it at home. Dizzy, sleepy, headache, irritable, anxious, congested. Right? That's the way I frame overstimulation response. And congested is your head feels like a grapefruit.
Okay, so here's the meditation, starting again. So long-term practitioners often show elevated resting gamma power over the parietal occipital midline, around the precuneus PCC and the right frontotemporal sites. This is from one of the studies by Lutz et al. And then during active practice, gamma power rises another 30 to 300% above each meditator's baseline. So, and these effects are largest for certain kinds of meditations, such as open monitoring, non-referential compassion, and jhana-like absorption, which is like deep concentration states. And smaller are absent for simpler meditations like breath counting. So these are advanced practitioners in advanced states of meditation. And we also know that the brain, operates through gamma theta coupling, that the gamma rides on theta waves typically. So the idea of increasing theta for meditation has value, but really there's a lot of gamma activity that's being filtered out in the EEG that we're not talking about. And it's also hard to do gamma training neurofeedback point of view because of the filtering in the skull. So we can get gamma effects using the helmet. That's the advantage of it. Okay, in psychedelics, we know because of the activation of the 5-HT2A receptors that when the psychedelics are administered, these promote high frequency firing in these receptors. And there are large alpha beta drops that loosen the predictive coding constraints of the usual personality. And then gamma may rise, particularly in psychedelics like DMT, which is a major component of ayahuasca. And bottom-up sensory signals start flooding the cortex. And if high-frequency assemblies desynchronize, like in psilocybin, then you also get these entropic effects in the brain, and you get into these altered states. Posterior gamma bursts are correlated with higher visual complexity also. So we know the brain produces high frequencies confirmed by intracranial recordings, and we played around with these. I talked about this. And so this was studied with 20 long-term meditators with 3 sessions, baseline, active, and sham stimulation, and meditation measures in pre and post QEEG with the NeuroPro 2. This is the protocol. So use a number of high frequency settings, 33 minutes, high frequencies for all the way from 120 to 1024, going in sequence, and 50% duty cycle, 100% power, and synchronized. Mystical experience questionnaire is used as a questionnaire for psychedelic studies. It's one of the questionnaires that's used. And it showed significantly higher readings in the mystical experience scale in the active session for the long-term meditators, higher scores in transcendence and in ineffability. So transcendence and ineffability show the highest effect sizes. So the sense of, being in this open, ineffable state increased people. And increased equanimity typically. There's the EEG analysis that shows that if you look at the basic bands and the baseline conditions, the sham condition, and the active condition, you'll see that the more significant effects actually show up in gamma. Here we have the baseline, the mid, and the sham, and the active gamma. There's also a little bit of effect in beta, a little bit. And the alpha just looks different. It's less clear. And there's some effect in the delta. But the basic hypothesis was that you're increasing energy, you're doing more high frequency stimulation, and you should get more gamma. In this case, certainly frontal gamma increased, and I'm surprised that it didn't increase posteriorly. Okay, so.
Do we get that?
Mhm.
The most recent study?
Yeah, that's it, yeah. Okay, so there's, many limitations. Most were not practicing the same meditation technique. That would have made a difference. Although they did practice open awareness, and the majority of them, it's a small study. And the other thing is that individual response varies. If you look at each subject, you get a much better idea of how they are responding. And we need to look at that, not just do average analysis. And the other thing I didn't ask the person in my RA to test currently is peak frequency changes. So we're going to do that as well. If there were any peak frequency changes, we're going to look into that. So, but that's one way I started the company Neurometrics, because my meditation students loved the effect of the meditation protocol, and they all wanted to buy the helmet. So it started selling itself. Okay, any questions on that? Yes.
I noticed that who don't really meditate or infrequent meditators did not benefit. It was the advanced meditators.
That's not actually true. That's a good question. We're going to study that. So my next study is going to be trying using the meditation protocols for supporting beginning meditators. And I do think it's going to show a clear effect, but it's not going to show an effect in one session. So we're going to have to change the study to basically provide like 6 to 10 treatments, as well as teach them a meditation technique, all the same technique, and then show that acquiring the meditation is better with measures. Should do measures and show, with and without the helmet. It's like a crossover study, and show that when they use the helmet, or no, not a crossover study. It will be 2 cohorts, and the cohort that used the study really improved much better. Yeah, actually acquired the meditation much better. Yes.
That one study you were just showing us, you only had the advanced meditators use the helmet once?
Yeah. So we had 1 active session, 1 sham session, 1 baseline session. We could get away with it with long-term meditators because they slide into a groove. It's what the helmet does is if you have a certain place you can go to, it'll take you there really fast. Like you go there in 3 days of meditation or on a psychedelic trip, or if you meditate for 6 hours, it'll just take you there right away. And then you can go further from there. It can also relax beginning meditators and help people who are beginning meditators, but they're less aware. And also they may not go there right away. They may need more than 1 session. Yeah. Yes. Does that make sense?
Yes, but I guess for lasting effects, so for the advanced meditators, they just need 1 session. Now, every time they meditate, they can go to that.
No, they already can go there. It just takes them really faster and takes them deeper. But they all want to buy the helmet and use it because they can go deeper and more ongoing with that. No, it definitely will help to keep doing sessions. Yeah. Yes.
So you would see those sort of profiles of the Q with an advanced meditator, like elevated gamma.
Yeah. Right.
And so do those effects persist longer if you use the cap, or?
Yeah, it persists longer, and the other thing is that what they want to do then is they want to go higher. So we don't stop. Then they don't want to stop at 1,000. Then they go 2,000, 3,000, 5,000, 7,000, 9,000, and even in like 1 minute, like I was demoing for Heather, for example. Heather Hargrave was here. She was she can go into these altered states like me and others, and so with her, we would do like I was doing 1 minute of 5,000, 1 minute of 2 minutes of 3,000, 1 minute of 7,000. And she was like, okay, I'm just really awake, open, and present now. That's what I need. So you can actually, higher frequencies correlate with higher states. And then as you practice, you deepen your experience in these higher states. And ultimately you want to individualize your treatment, and you can increase it over time. You can increase the frequency you can access and how much it can help you over time. But if you try to go do it too quickly, then you may find no effect, or you may get some negative responses. So also high frequency stimulation may bring up more old material to process therapeutically. So, it's a powerful effect on the whole system. Yeah.
We've got Catherine.
I think let's see what's in the chat.
Well, there was that one study that just came out.
Yeah.
With the Neuradian.
Okay, you want to talk about that? I can't find it.
It was the one you transferred
Yeah, I know, but where is it? I think we're pretty much done.
at the end.
Can I ask one more?
Yeah.
Very useful.
Take care, guys.
So can you comment on ADHD, like based on your experience? Because you were saying that, and it makes sense that for neurodegeneration, it has to be used forever, but I would.
No, that was for older people with cognitive decline. Yeah.
It makes sense that it needs to
Yeah,
be used forever,
right.
but for ADHD, we would think that they get at some point to an improvement that
That's right.
stabilize over time.
Yeah, for younger people, you won't need to use it forever.
Yeah, but could you comment a little bit more on your experience with ADHD?
Well, what I would do is, yes. So you know, depends on the basically the what do you call it? The phenotype. So if you know the phenotype of ADHD, then you treat them according to the phenotype. You look at the Q. So it's important to get a Q. You know, are they high alpha ADHD? Are they high theta ADHD? Are they high beta ADHD? So each one will be treated according to their phenotype, and you're looking at the quadrants and the frequencies that you want to stimulate them. And then typically, you know, typically there's metabolic issues of, you know, or injury in the brain. So the light is going to help to heal the metabolic issues in the injury, and the frequency application is going to help to heal. It's just like you would do neurofeedback with them. So that's how you would approach it.
We crossed the time.
Okay. Thank you.
Anybody who is interested in research doing intranasal 1070 for the long COVID,
Thank you all.
it's a compliment. So if anybody's interested, I've got some at the